Hey everyone, very good evening. Welcome, Vanakkam, Suswagatam. Hey everyone, just do let me know, can you hear me, can you see me? If yes, I'm perfectly audible as well as visible to all of you. Just do let me know in the chat section. Suswagatam, and show me green hearts along with some fire in the chat section if I'm perfectly audible and visible. I want to see in the chat section that what's the reaction. If yes, the voice is absolutely clear. If I am perfectly audible as well as visible, I want to see green hearts along with some fire and some emojis. And everyone, yeah, that's really awesome that each and everyone can hear me, can see me. That's really awesome. This is the batch which I've got at Offline Center Unacademy, Jaipur, for giving the best result in JEE as well. JEE Mains result has been declared, so this team has given the best rank from here. Yeah, my dear students, now as I can see, Pradibha, Ramiz Ahmed, DC, Sanchu, Chaitanya is there, Awakened, that's really awesome. Yeah, I will teach you each and everything from the scratch. The flow will be first chapter. I will let you know. Before that, I want to see that everyone is over here. Let me check it out. That is everyone present or not? I want to see your attendance in the form of, yes, scratch the like button, smash the like button. That will be your attendance. That is going to be your attendance. I want to see that everyone is over there or not. Now, do let me know in the chat section the chapter coordination chemistry, which holds a hell lot of weightage. And in coordination chemistry, I will move according to NCERT sequence. I will teach you each and everything from the scratch. I don't know for how many hours, because you know that in this inorganic chemistry, the main is coordination chemistry and then D and F block elements. Little bit about P block, because P block too much is not there. Only the trends and the table is there. So first, I will teach you coordination chemistry. But for coordination chemistry, a little bit knowledge of D block is also necessary. First, I will give you that knowledge, and then I will move through coordination chemistry. I will teach the topic and the questions based on that topic, right? Number of questions. So, are you ready for that? Just do let me know. Marks. You know that coordination chemistry is the most important chapter. If I talk about in whole chemistry, the maximum weightage is of coordination chemistry, and at least you can think 20 marks from this chapter only, coordination chemistry, 20 to 30 marks. DNF, at least DNF you can get 10 to 16 marks. So at least 35 marks you are going to get from coordination chemistry and DNF block, because coordination chemistry is having roots in solution chapter, that is colligative property, in electrochemistry also, conductance, solution, elevation, boiling point, depression and freezing point. So coordination chemistry is very, very important. Are you getting my point, kids? Just to let me know in the chat section. Yes, you got it. You got it, what I'm talking about. Do let me know in the chat section if it is everything is clear. I want to see green leaps in the chat section. Green leaps. Okay, now so let's it go. Now do let me know in the coordination chemistry, which topic do you think to be the most difficult topic? Werner's coordination theory. Let me give you the options. Which topic do you think to be the most difficult? Your most difficult topic, I want to see that. Mark for most difficult, most difficult. I will start from there only, right? Most difficult, first option, isomerism. Second topic, Werner's coordination theory. C option, color. D option, hybridization. A, B, C, D. Marked for A, B, C, D. You must have seen in this GI and OI, optical isomerism. GI and OI, I have marked, and I want to see your reaction in the chat section. A, B, C, D. A, B, C, D. Just go for this. Isomerism and CFT. C, A. It's maximum people are going for A. A. Okay. Isomerism and CFT. Yes. So that your options. Everyone, just I want to see your response. Write down along with A that isomerism portion. If A is isomerism, then write down isomerism also along with A. P block also, because P block only an experienced teacher can tell you what is important from P block. But write down what you want. Crystal field theory and color. Okay. Isomerism. Maximum people are going for isomerism. Yeah. And isomerism. So I will start from isomerism. I will make you perfect. I will make you perfect in isomerism. So everyone is going for isomerism and color and CFT, right? Crystal field theory. Okay. So let's set go with isomerism. Okay. That is public demand, students demand, and I will make you perfect in isomerism, crystal field theory and color theory, so that full marks you are going to get. Okay. Now for this, show me once again the green hearts and smash the like button. I want to see that what I am going to do for you. I will get green hearts and the everyone, if you start, I will start from the scratch. Even if you are having zero knowledge of coordination chemistry, I will teach you. I am going to start it from the scratch, and I will take you up to the best rank, the first rank. Yes, Lalita, yes. I will start from the scratch. So everyone, I want to see green hearts. So just do let me know. Your Baba can make you perfect in isomerism, and that is isomerism of what? Isomerism. And in isomerism, the starting point is isomerism. Let me tell you the sequence. On number 1, I will tell you isomerism, that is GI will make you perfect. Then on second number, isomerism, OI, I will make you perfect. Then third number, the CFT, and in the CFT I will tell you hybridization and color. Okay, this is the starting sequence. Agreed? Got it? Everyone? Okay. Now kids, I'm going to start with isomerism. How to calculate total number of geometrical isomers. So ready, steady and go. Ready, steady and go. I'm starting kids, right? Okay, let's set go. Let me take one blank page here, and let's set go. Everyone just see to it. The isomerism. isomerism. And in isomerism, we are going to start with, right now we are going to start with how to calculate total number of GI, total number of geometrical isomers. Now, I will give you three ways. There are three approaches by which you can solve. There are three ways, three methods, not only one method. I will tell you three methods. One is table. I will give you table to cram it. Second method, I will give you grouping method. And this is maths, PNC, permutation and combination. And third way, I will tell you the visualization. So you will become perfect. You are going to become perfect. For this, how to calculate total number of GI, I'm going to tell you three methods. One's the table method. By cramming it, you can get the answer. Grouping method and visualization method. Okay, if you are a zero in this, you will be able to solve each and every question. That's my promise. So let's go and let's start. So what we are going to deal with, kids, what I've told you, we are dealing with, yes, geometrical isomerism of coordination chemistry. Geometrical isomerism of coordination chemistry. GI, geometrical isomerism. Just see. Now, if I say the compound is tetrahedral, if the compound is tetrahedral, I will write Ma4. These four are the ligands, and this is central metal atom, and this is A4, and this is tetrahedral. And remember that tetrahedral compounds will never, whether it is like this, or it is like Ma3B, or it is like that Ma2B2, or it is like that Ma2BC, or it is like that MABCD. Whatever the ligand, irrespective of ligand, it will never show GI if it is what? Tetrahedral. Because to show GI, at least something should be planar. So tetrahedral compounds can't show GI. Tetrahedral. One thing clear? Tetrahedral compounds can't show GI. Perfect. And if all the four ligands are different, M, A, B, C, D, then this metal will become chiral. Chiral means no plane of symmetry, no pos plane of symmetry, no center of symmetry. So this will be optically active. So what I have written, tetrahedral compounds can never show GI, but yes, they will show optical isomerism if all the four ligands are different, just like chiral carbon. If all the four ligands are different, in case of all four ligands are different. This point is clear? If this point is clear, now let me show you about Ma4. That means they can be tetrahedral or they can be square planar. So let's see if Ma4, or it is Ma4, Ma3B, Ma2B2, Ma2BC, A, B, C, D. In case of a square planar, if it is being square planar complex, let me start from M, A, B, C, D. M, A, B, C, D will look like this. M, and if I fix A, just you see in front of A, once the B will come, so C and D will be opposite. Second, I can write M, A is fixed. See, A I have kept fixed. Now you will say, sir, why only A you are keeping fixed? You can fix B, you can fix C, whatever. So let's fix one so that way we can easily understand. M, in front of A there is B, in front of A there can be C. Now what is the next case? In front of A there can be D. Now what I'm saying, kids, just try to understand. This is square planar. If I say this is being a square planar, let me write down square planar is like this, square plane is like this, square plane is like this. So if I say that in front of A there is B, so C and D are opposite. In front of A there is C, then B and D are opposite. In front of A there is D, then C and B are opposite. So how many GI are there? Just try to understand, those who don't know anything. So let me draw a square plane is like this. This is being a square planar. Can you see, kids? Those who don't know anything, square planar, it is planar molecule. So it will show 3 GI. Are you getting any point? If you are getting, then first of all, do let me know in the chat section that, first of all, are you able to understand anything? Let me check it out. How many of you are able to understand? Because if you can't understand a square planar complex, you won't be able to understand anything. You won't be. Let me give you the feel of this also. Let me give you a square planar feel on next page. Just see, if I say it's like a square planar. Just try to understand what is square planar. If I say this is one plane, if I say this is one plane, this is one plane, and if I write down here is central metal atom M, and if I write down here is A, so A opposite to A, if I fixed B, then that side there should be C will be opposite to D. Now you are able to understand. Now once if I am keeping A to be fixed, if I rotate, once C will come over here, once D will come over here. So if there is central metal atom and all 4 ligands are different, suppose if I say fluorine, chlorine, bromine and iodine, so this square planar, if this is square planar, 2 things are there. If it is tetrahedral, if the hybridization is coming sp3, this compound's hybridization is coming sp3, so it will be tetrahedral. So tetrahedral compound will never show GI. If I say GI, no GI, but all 4 ligands are different. So this will be optically active. It comes from the hybridization, optically active, then its shape will be tetrahedral. But if I say it is DsP2 hybridization or sp2d hybridization, then it is square planar complex, and square planar will show GI. GI it will show, but OI it will not show. Why OI it will not show? Because it is a plane. If I take square planar complex like this plane is square planar complex. Let me take one plane. This is square planar complex. Here is central metal atom, and if I keep one ligand this side, one ligand over here, one ligand over here, one ligand over here, all the 4 ligands, whatever the ligands, they are atoms. Now if I cut it, what the atom is going upside, the same part will come downside. So there is plane of symmetry. Sandwich plane of symmetry means you can divide the whole compound in two equal parts, so that upper part will be the exact mirror image of lower part. There will be the plane of symmetry. Are you getting my point? So square planar complex, whatever the type of square planar complex is there, it will never be optically active, because there will always be plane of symmetry. Are you getting my point? Whether I talk about this compound, whatever the type of compound, see, if it is square planar complex, if it is being a square planar complex, whatever is the type, all they will be optically inactive. Optically inactive. They can never show optical activity, but yes, they can show GI. Are you getting my point? First of all, do let me know this much, what I'm talking about. Is this much clear, kids? Then I will move ahead, because only a little bit brain you have to apply. Are you getting my point? Show me green hearts if you are able to get it. Sahana got it. Yes, sir, clear. Sanju, Mahalakshmi, everyone. Kids, I will move step by step, but I need your reaction. I want to see your reaction. Very good. Yeah, Vishal, clear. Wow, awesome, kids, awesome. Now see. If I draw for MA to BC like this, 2, this was showing 3, 2, this will also show 2. No GI. Now you will ask for MA to B2. Let me draw for MA to B2, MA to BC. These two, right? Y2. Let me draw over here. If I draw like this, see to it. If I write down central metal atom, and if I say this is MCl2Br2, this is example of Ma2B2, right? So if I write down M, this is chlorine, and this is also chlorine. See, they are vertically opposite. They are at 180 degree. Can you see? 180 degree means vertically opposite. So they are anti to each other. 2 chlorine anti to each other. So they are trans, because if I draw bromine, they are also anti to each other. So I will write down this is transform. Now, how will you find out what is the cis form? M, and if I write down chlorine over here and chlorine over here, just see, they are on the same side. Then bromine will be over here, and bromine will be over here, bromine and chlorine. So this is cis form. So these two are GI of each other. These two are what? Hey, who are you? You are my GI. And this is asking with that. Hey, who are you? You are my GI. So they are like sisters. Sita and Geeta, Stans and Sis. These are two sisters. What the relation we are having? You are my sister, I am your sister. What's your name? My name is Trans. What's your name? My name is Sis. What's the relation we are having? We are sister of each other. We are GI. We are configurational isomers. So the relation is GI. You are my GI. I am your GI. Clear? This point clear? I want to see your reaction. If it is getting clear, I want to see that. I want to see that reaction, kids. Fast. Kids, I want fast, then only I can move to octahedral. Once the square planar is clear, then only I can move to octahedral. Thank you. Now, whatever till now I have told you, I would like to write it on a single page. I want to write it on a single page. Let me write down on a single page whatever the things I have told you. Now see, why the next one is unable to show the, see, if I say M, if I say MA4, why it cannot show? See, why it cannot show? If I draw it like this, and I am writing M, for example, M, central metal atom can be anything, NCl4. So if I am writing Cl, 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 so whatever Cl I am writing, wherever Cl I am writing, all they will be same. This Cl over here, that Cl over here, this Cl over here, wherever I am placing Cl, only one form I am getting, only one. There is, if I say one, Mr. X is having one daughter, Sita. So is there any other daughter that Sita can say you are my sister? No. Mr. X, earlier Mr. X was having how many sisters, how many daughters? Three daughters. And in this case, Mr. X was having two daughters. So this was sister of this, this was sister of this. You are my GI, I am your GI. But see, here all the forms are identical. Any form you are going to draw, they are identical. So no sister means no GI. It will have no GI. Now second one, if I say that I am having MA3B, just see to it, MA3B. If I place chlorine, now one is different, bromine. Now whatever form I am going to draw, this bromine will be opposite to this chlorine and this bromine will be cis to this chlorine, only one form. So this one is also not having any sister, MCl3B. So they are one and one only, so can't show GI. Can't show GI, can't show OI, can't show GI and OI. Why can't show OI? Because they are square planar, because they are having plane of symmetry. Plane of symmetry is present, so can't show I. Why can't show GI? Because they are one and one only. Gets two, let me know. Till now, is it clear? Till now, fast. Once it is clear, I will see over here. So keep on showing, spreading green hearts, because you are getting it. Then only we will get the way for your octahedral. Octahedral you can understand only in that case if you are able to understand this. Otherwise, pos and cos. How many people don't know pos and cos? Plane of symmetry. Let me tell you the plane of symmetry so that you can understand. Otherwise, you won't be able to understand. See. Let me show you plane of symmetry. First, what is the meaning of plane of symmetry? Plane of symmetry. An imaginary plane which divides the whole compound in two equal parts so that one part is exact the mirror image of second part. Because all these things, once if you want to apply your brain, it should be very, very clear that what is plane of symmetry, if you can understand. See, now, if I say that, if I give you the example of this compound. Okay, let me show you this bottle. This bottle, do you think it is having plane of symmetry? Do you think it is having plane of symmetry? Let me see in the chats. This bottle is having plane of symmetry. Do let me know. Is this bottle, or let me take this bottle, is this bottle having plane of symmetry? Do let me know. Yes. If I cut it from the top, that from here, it will get divided in two equal parts. This part will be the mirror image of this part. I will say vertical plane of symmetry. What word I am going to use? Vertical plane of symmetry. Vertical plane of symmetry. See over here, vertical plane of symmetry. If I write down like this is A. Do you think this A is having any plane of symmetry? Yes. How should I divide it? If I divide it from here, it will get divided in two equal parts, so that the right hand side is the exact mirror image of left hand side. So this is a plane of symmetry. It is dividing A into two equal parts. So this is vertical plane of symmetry. Now, if I give you another compound, if I write like this, if I put the bottle over here, now if you cut it from here, will you get plane of symmetry? No, because this side is different from this side, no plane of symmetry. But if you cut it sandwich, horizontal plane of symmetry, the upper part will be the exact mirror image of lower part. So see, if I draw B, if I draw this B, just to let me know, do you think, is there any plane of symmetry? Is there any plane of symmetry? So you will say, yes sir. If you divide it from here, there is one plane of symmetry. There is one plane of symmetry. Can you see, kids? This is your plane of symmetry. This will divide the whole. This is horizontal plane of symmetry. Horizontal plane of symmetry is present. So the compound can't be optically active. Everyone got it? Now, if this smaller thing you are able to understand, I will teach you this thing in the organic chemistry. Just to let me know, is it clear? Because once you are getting it, always show the green heart so that you can get it. Yeah, very good. Now see, fantastic. Now see, kids, if I draw compound like this, if I draw a compound like this, do you think there is plane of symmetry? Yes. Either you can cut it from this side, or you can cut it from here. There is plane of symmetry, vertical plane of symmetry, horizontal plane of symmetry. Now, if I do one thing, that is, if I write down like this, and if I put here one atom like this, chlorine, hydrogen, chlorine, hydrogen, do you think there is plane of symmetry? Yes. If you cut it like this, that portion will be the mirror image of this portion. If you see, there is plane of symmetry. Can you see there is plane of symmetry? Can you get it? Plane of symmetry is there. Now, if I draw a compound like this, if I draw a compound like this, just see to it. If I put chlorine over here and chlorine over here, bromine at this place, then you see diagonal plane of symmetry. What is diagonal plane of symmetry? If I say this is the square plane, and if I turn it like this, if I put something over here, chlorine, and the same thing, chlorine at this place also, or anything, bromine, iodine, anything, and you cut it, diagonally cut it from this white portion, and come to this black portion, you will get diagonal plane of symmetry. Are you getting my point, everyone? So it is having diagonal plane of symmetry. This is known as diagonal plane of symmetry. I hope everyone got it. I hope that everyone got it. This is known as diagonal plane of symmetry. So the compound is optically inactive. So let me summarize. Once the plane of symmetry is clear, now let me summarize. Before summarizing, it's my request, humble request, that those who are able to understand, show me green heart so that I can move ahead to give you that figure what we actually were searching for. Now see, kids. Summary till now what I have taught you. Summary of that. Let's summarize. Ma4 or we can say sp3 hybridized tetrahedral, and let me divide it. Ma4 sp2d or dsp2. In that case tetrahedral, in this case square planar. Now let me tell you, if they are like this, Ma4 ligand, all four ligands same, Ma3b, Ma2b2, Ma2bc, MABCD. Now if I say GI and if I say OI, then they will never show what? Tetrahedral never show GI, because they are not planar. OI only in one case, this is chiral. This is chiral atom, or this will show. OI they will never show because they will have what? They are tetrahedral, they will have plane of symmetry. Plane of symmetry will always be there. This point is clear. Now if I go to that side and if I draw it, Ma4, Ma3b, Ma2b2, Ma2bc, MABCD. Now if I write down GI, OI, now if they are square planar, so it will have 3 GI, it will have 2, it will have 2, they will never show. And if I talk about OI, no one will show OI because they are always having plane of symmetry. Now this is the summary till now what I taught you. Summary you're liking, kids? This is the summarization. Kids, do let me know. So now I will move towards octahedral. Then I will move towards octahedral. But I want to see that people are able to understand or not. Kids, fast. Now I'm going to move towards octahedral. I want to see your love and support, kids. Hit the like button. Smash the like button. Everyone. Oh my God, you're taking too much time. I want quick response, quick, and hit the like button, smash the like button. If you are new to this channel, subscribe it, kids. All clear, very good. Now, I'm moving towards octahedral. See. Same, octahedral. Octahedral. Very important, octahedral one. Octahedral GI, geometrical isomerism. You know that in case of octahedral, how many ligands are there? Do let me know in the chat section how many ligands are there in octahedral. How many ligands will be there in octahedral? Do let me know in the chat section, everyone. I want to see how many ligands will be there in octahedral. If you don't know, then what you are going to do? How many ligands will be? 6. Very good. 6 ligands. Everyone, very good. Fantastic. Thank you for quick response. Now see how many possibilities are there. How many possibilities are there? See, I can write down M and all 6 ligands are same. M, 5 ligands are of one type, one ligand is different. M, 4 ligands are of one type, 2 ligands are different. M, 4 ligands are of 4 types, but these are not same. One is B, one is C. Now M, no other possibility. M, A3, B3. Now MA3 remaining constant, and this can be changed. B2, C. Now MA3 remaining constant, but I can change all 3. B, C, D. Now no other possibilities and MA3. Now write down MA2. Now how many possibilities? A2, B2, C2. Now A2 remaining constant, MA2, B2 remaining constant, I can write down CD. Now I can change M, A2 remaining constant, but B, C, D, E. Now only one possibility, M, A, B, C, D, E, F. Let me count how many we have drawn. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Everyone, if you are getting this sequence, are you able to understand? First two, let me know. Is everyone able to understand the sequence? What I mean? Now see. Now see kids, this one cannot show GI 0. 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 This can show GI 2, 3. Now this can show GI or not? MA4BC, just to let me know. MA4BC, MA4B2, these have written 0, 0. Just to let me know they can show GI or not. This can show GI or not, MA4B2. I can write B2 vertically opposite. I can write B2 in system, then this will show GI. But right now let me complete the table, then I will tell you the visualization. 2, 2, 2, and this one MA3B3 is 2. Now MA3B2C 3, then after 3 4, after 4 5, after 5 6, now reverse 6 9, now 15, 6 and 9 15. Remember 0 0 2 2 2 3 4 5. How to remember? 0, 2 times 0, then 2 2 2 3 times, then after 2 3, then 4, then 5, then 6, then reverse 6 9, and 6 9 15. This is the cramming part. Now how many of you want to know the grouping part? This is the cramming part. This is totally the cramming part. If you can cram it, it's fine. Cramming part. Now I will show you the grouping part and then visualization part. How many of you got it? First of all, tell me in the chat section how many of you got it, the cramming part. Do let me know the cramming part. I want to see in the chat section how many of you are able to understand the cramming part. Do let me know, kids. Everyone. This was the cramming part. What are ligands? Ligands I will tell you, and that's why I have tell you from where to start. Ligand I will tell you, that is the starting part, the one who is donating electron to the metal. Lalita, they are, yeah, cramming part clear? Now, let me tell you how to get it with the grouping part, okay? Let me tell you the trick, Baba HSP's trick. How many of you want to know Baba HSP's trick for calculating GI? Calculation of GI, calculation of total number of GI. Baba HSP's trick. Baba HSP's trick to get full marks in your exam. If you need this trick, show me rose hearts, rose color hearts, then only I am going to give you this trick. I want to see rose color hearts, not the green hearts, rose color hearts. Then only I will give you a trick. Otherwise, I am not going to give you a trick. If you want to get full marks in examination, then rose colored hearts for Baba HSP. Yeah. Pair. You have to make pair. No. You kids not to make pair. Here, the ligands should make pair. Ligands are going to make pair. That is, trick is ligands making pair. Ligands making pair. Ligands making pair. Now, any example you can take from here. Any example, if you can take from here, let's say Ma4BC. Let's take one example from this. And one more, any example of your choice, any one from your choice. Let's take Ma3A2B2C2, Ma2B2C2, okay? Ma4BC and A2B2C2, right? First Ma4BC, right? Ma4 and B2, right? Ma4B2. How can you write Ma4B2? We can write MAA one pair, AA one more pair, and B one more pair. Now, any other pair you can form. You can write down MAA and this AB and AB. Now, is there any other way of writing it? One pair, one pair, one pair. Is there any other way of writing it? Just to let me know. I have written like this, I have written like this, I have written like this, I have written like this. Now, any other way this compound can be written? Is there any other way of writing it? So, X is GI of Y and Y is GI of X. So, they are GI of each other. GI of each other. How many of you got it? They are GI of each other. Now, let me take another example. Just see. If I take this example, Ma2B2C2, suppose I don't know the answer. Although I know the answer is 5, but just think of, I don't know the answer, it is 5, Ma2B2C2C. Ma2B2C2, how I can write? MAA B and CC, one type. Now how I can write let's keep AA like this only. What I can do, exchange BC and BC. One more I have written. Now third, what I can do, M, let me keep BB over here, BB over here, AC and AC I can do. Now let me keep M. Once AA I have kept constant, once BB I have kept constant. Now I will keep CC constant, then AB, 4 I have written. Now which one will be the fifth one? Let me exchange all. Let's see. M, A, B, A, C. Now what I can write? A 2 times, B and C, and what is left? B and C. It is repeated. A 2 times, B 2 times, C 2 times, and it is repeating. No, it's not repeating anywhere because no one is common. All 5 I have written, 5 GI. Perfectly, without any cramming, total 5 GI I have written. Am I great? Are you great? Just to let me know in the chat section. No pair is getting repeated. No compound is getting repeated. There are total 5 GI. This part is really great or not? Do let me know in the chat section, everyone. Then I will teach you how to find out optical isomers. First of all, do let me know, kids. First of all, I want to see in the chat section. Kids, everyone, just do let me know in the chat section. Gulabi Dil, yes, kids. Show some enthusiasm. Don't think that if you are not participating in the chat, it will be okay. No, it's not okay, kids. And what is this? Baba, drink water. Oh my God, Mustafa, thank you. You are really genius. Really, you are genius. Kids are thinking for Baba. Thank you. Now, any other? Yeah, crystal pair splitting I will teach you. Now, any other example you want to know from here? Any other example? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. The isomerism which was looking idiyappam murku, Baba HSP made it romba sulbham. Arpudham, we will get it. We will be. Chemistry padikyaradu customer. If you're thinking, no, ille, it's romba sulbham, it's easy. Now, let me see what you are writing. Which one? 11th. Lalita is going for 11th. Oh, everyone is going for 11th. You kids are very smart. You are going for 11th. Okay, let's see. Let me write down 11th. If I don't know anything, how to solve 11th one, just see everyone. M, A, B, C, D, E, F. First of all, do let me know whether I'll be able to draw all 15 or not. Whether I will be able to make pairing of all 15 or not. Yes, let's try. M with A, first I will keep with A. Let's take F to be constant. F. Now what I am going to do? What I will do? I am having B, C, D, E. Now with BC, what I can do? I can write BD. Now BE. What are you doing, sir? Okay, let me tell you. M, A, F, BD. Now what I am saying? I kept BD, then CE is there, BE, then CD is there. Now kids, you must be thinking, sir, what are you doing actually? Should I tell you how I am doing it? You want to see the magic, how I am able to do it, kids? How many of you want to see the magic? How? Okay, first let me show you the magic. Just wait. First let me show you the magic. Now M with A, I will keep E constant, so I will draw 3, M A E M A E. So what will be there? What is left? A and E I have taken, so B, and what is left? B and C and D. What is left? A, B, C, D. F is left. Now B with C, B with D, B with F. So what is left? BD is over here, BD is over here, CF is over here, BF is there, CD is over here. So I have got these many. Now if I write down M A E, I have taken E, D, 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 M A D, M A D. Now so what is left? AD I have taken, B, C, E, F. Now B with C, B with E, B with F, B E, B E, C F, B F, B F, C E. Now this I have taken. Now let me draw M A D. A D I have taken, A D, A C. A C I have not taken, M A C, M A C, M A C. Now what is left? What is left? AC I have taken, so B, D, E, F, B with D, B with E, B with F, B with F, B, E I have taken, so D, F, B, F I have taken, so D, E. Now what is left? What is left? C, M, A, C I have taken, A, C I have taken, so M, A, B I have not taken, A, B, nowhere I have taken A, B, M, A, B, M, A, B, M, A, B. Now what is left? What is left? B, A, B I have taken, C, D, E, F, C, D I have taken, so C, E, C, E, so D, F. Now C, F, so C, F I have taken, D, E. How many there are? 3, 2 the 6, 9, 12, 15. Now you must be thinking, sir, how you are able to do it? How many of you are thinking like that? How I am doing this? How I have drawn all 15? How many of you want to know this trick? How many of you are interested in this? Baba's maths permutation and combination is superb. It's to let me know how many of you want to learn it. How many of you want to learn this? Gets to let me know in the chat section. How many of you want to learn this? Kids, really, if you want to know this, do let me know. Fast. Now see. Yeah, I have taken this trick from square planar only. I will tell you. I have taken this trick from square planar only. Just see. Let me show you. Let me tell you how this trick is working. See. If I say, in the starting I have taught you, see what I have taught you is in square planar, that if I keep M, A to be the constant over here, A to be the constant, now in front of A I have kept B. Now in octahedral, what is there? Just see, let me rub it. Octahedral, let me first draw octahedral. Let me draw octahedral. This is octahedral, right? Clear to all of you? First of all, do let me know, have you seen octahedral? This is central metal atom M. This is octahedral, 6 ligands, 1, 2, 3, 4, 5, 6. Now, what I have done, A I have fixed. Then if I kept, I am having M, A, B, C, D, E, F. 6 ligands. A is fixed, not A, anything you can fix over here. Now once with A I have kept F fixed over here. Now how many are left? 3 ligands, B, C, D, E. Now tell me, this is octahedral, this is octahedral. What if I tell you these 4 ligands? In the starting I have shown you these 4 ligands, if they are moving, how many? If they are rotating, these green part. If I write down M, B, C, D and E, how many GI they have shown? Only 4 ligands. When it was square planar, in case of square planar, what I have told you, how many GI it has shown? How many GI? It has shown 3 GI. Are you getting my point? Once I told you about a square planar, in case of a square planar, it has shown 3 GI. So once the green part is rotating, this is fixed. Suppose yellow part fixed, yellow fixed. Now rotating greener part, rotating green, how many GI we will get while rotating? Into 3. Are you getting my first point? In vertically opposite of A, I kept F, and rotating green part, we will get 3 GI. How many of you are getting this simple thing? I told you in square planar complex that this will form 3 GI. Do let me know first of all, then only you can understand. Are you getting this much? How many of you are getting this much? Just to let me know, everyone in the chats, I want to see. What's going on? Fast, quick. Okay, once again. Okay, if you want to understand it once again, I will teach you. I will tell you, no problem. But do let me know in the chat section. I will tell you, but once do let me know in the chat section. Yeah, very good. Now see, let me tell you once again. See, everyone try to understand what I'm telling you. Recap of GI, what I have told you in square planar. In square planar, I have told you, once you are having 4 ligands different, M, A, B, C, D, all 4 ligands different. In case of all 4 ligands different, how many GI it has shown? First, do let me know. It has shown 3 GI. What were these 3 GI? 3 GI, that if I write down like this, 1 box, 2 box and 3rd box. So if I keep here central metal atom, now what I can do, in against of A, I have written B, against of A, I have written C, against of A, I have written D. How many possibilities? 3 GI. What if I have kept like that? Now I can keep here C and D, here D and no, E is not there, A, B, C, D. So B here, A, D, so B and C. So total 3 GI. If any 4 ligands are different, always 3 GI. Always 3 GI. This point is clear. Always 3 GI. Now at least show me green hearts for this, then only I can tell you about octahedral. The basic part is always 3 GI in case of 4 ligands. Oh my God, kids, if you really want to become genius, if you really want to visualize, keep on showing. Better to become smarter. Okay, now see. Once this part is clear, just see. If this part, once it is clear, so see, if I write down here the same thing, if I draw over here, just see, if I draw over here, right, 1 2 3 4 and the fifth one, just see what I'm saying. There's in the center, there is central metal atom, and let me fix it. If I write down over here metallic part at this place, now what I'm saying, just see, if I keep A to be fixed over here, right, A to be fixed over here, and against A once I have taken F, now how many are left? I'm left with what? I'm left with B, C, D, E. Now if I keep on rotating this blue part, so once against of B I will get D, then C, then E. Once A and F are fixed, I will get 3 GI. This part is clear. Now if I keep here A is fixed everywhere, A is fixed, A is fixed, A is fixed. Now against A I have taken F. Now after A, F, I have kept E. Now how many are left over here? I am left with B, C, D and F. Now this blue part is rotated. Once again I will, these are fixed, upper one and lower one fixed, blue part is getting rotated, I will get 3 GI. Now against A I have kept A, B, C, D, E, F, E, then D. Now how many ligands are left over here? A, B, C, E, F. I will rotate. Once again I will get 3 GI. Now A is fixed, against it I have kept what? D. Now I have kept C constant. Now 4 ligands are left. A, B constant, 4 ligands are left. So 3 GI, 3 GI. Total how many GI I have got? 15 GI. All total 15 GI I have got. How many of you are able to understand? Do let me know, kids. A and C. So B, D, E, F, A and B, C, D, E, F. This is the visualization and grouping part. Do let me know. It's how many of you got it? Good evening, Reddy Sai, welcome, Reddy Sai, welcome. Now, if you are able to understand this much, then I will tell you optical isomerism. I will show you optical isomerism, but do let me know how many of you got it. Clear. Wow. Now let me tell you the optical isomerism. Let me show you the optical isomerism. Are you ready? Are you ready for optical isomerism? We need, for a compound to show optical isomerism, we need perfect pair. But first I will write down the table for cramming part. Table for cramming. Just see table for cramming. But you have to help me. Let me write down M. First A6. Then what I have written? MA6. Then M. A5. B. Then M. A4, B2, then M, A4, BC, then M, A, A3B3, then M, A3B2C, then M, A3BCD, then M, A2B2C2, then M, A2B2CD, then M, A2BCDE, then M, ABCDEF. How many are they? 11. Earlier also I've told you, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11. Now let me write down here total number of GI and here total number of enantiomeric pair. At this place, total number of GI, total number of enantiomeric pairs. Ready, everyone? I'm going to show you this thing. Just see to it. Now see, its GI already I have written 0, 0, 2, 2, 2. Do you remember? 3, then 4, then 5, then 6, opposite to that 9, then 6, 9, 15. This already I have told you, right? Already I have told you. Now total number of enantiomeric pairs. Total number of enantiomeric pairs, just see to it, gets everyone. Now 0, for this 0 can't show, 0, 0. Now for this also 0, for this also 0. Now for this 0. How many zeros are there? 6 zeros. Remember that 6 zeros. It will start from here. 1, 1, 2, 6, then 15. 15 enantiomeric pairs means 30 optically active isomers. Remember that. Enantiomeric, one pair means 2 enantiomers. If there is one pair, that means 2 optically active isomers. 2 optically active isomers. Are you getting my point? In one pair there are 2. Yeah, in one pair there are 2. So 2 optically active isomers, and 15 means 15 to the 30 optically active isomers. Now this is the cramming part. This table is cramming part. Now how many of you want to visualize it? How many of you want to visualize it? And I can tell you the answer with the visualization part. I can tell you with the grouping part, pairing part. How many of you want to know through pairing part, and how many of you want to know through visualization part? Pairing, no need of visualization. Visualization, total to C plane of symmetry. Ma2B4. Let's see Ma2B4. This is Ma2B4 only. See, if I write down A2 then B4. Who has asked this question? Ma2B4. If you write down this A2, this will become B4. Clear? Ma2B4 is like third one only. I hope you got it. Somebody has written. Now How many of you want to know the pairing part? In perfect pairing, there is no visualization. Perfect pairing, if you want to understand through perfect pairing, no visualization is required. How many? How many of you want to go through perfect pairing? Okay, then show me. Those who want to go through perfect pairing, show. Let me give you options. This one, if you want to go through perfect pairing, A option is perfect pairing. Now let me see. Baba HSP strict. Baba HSP strict. First option is perfect pairing. Perfect. In GI I told you pairing. Here perfect pairing is first option. Second option is visualization. What you want to go with, perfect pairing or visualization? Do let me know in the chat section. I will tell you that thing only. And for perfect pairing, green heart, you have to show me green heart, and visualization, you have to show me rose heart. For perfect pairing, green heart. For visualization, red heart. Perfect pairing, green heart, visualization, red heart. Let's see what you are going to show. Oh, Linges want both. Oh my God, Linges needs both. Oh, Rangaswamy, you need both. My God. Yes, kids, yes. So first I will tell you the pairing and then the visualization. First with pairing and then with visualization, right? First with pairing and then with visualization. Let's see. So with pairing, let's go with first with pairing, perfect pairing. You know perfect pair, you know very well perfect pair. What do you mean by perfect pair? Tell me perfect pair. I'm going to write pair. Tell me AB is a perfect pair, or B2 is a perfect pair, or C2, A2. Out of these four, which one is perfect pair? You know, pair means what? Perfect pair. Pair can be of anyone. Perfect pair means hero and heroine. Okay. So which one is perfect pair? A, B, C, D. Do let me know. Out of four, which one is perfect pair? First one is perfect pair. So there, they should not get repeated. That is going to form perfect pair. This is perfect pair, means this is different from this. Okay. Now, let me take any example. Out of whatever the things I have told you. Let's select any example. Which example you want to take? Tell me. Which example? Any example. Randomly tell me any example. Let's take M A2 C2, right? Ma2B2 C2, right? First, let's make the pair like GI. How many pairs we have drawn for this? Just see. Ma2, then B2 C2, 1. Ma2 BC, now M B2 Now AC and what B2 I have taken AC, B2 I have taken AC. Now M C2 I have taken AB. Now M AB AC, and what is left? B is left and C is left. Now see, these are the 5 GI. Do you remember? Earlier we have done 5 GI, 5 geometrical isomers for this. Now, is this having perfect pair? First one, no perfect pair. They are same. They are different. One is different, but they are same and they got repeated. Remember that? To show optical isomerism, compound must have, first thing, perfect pair, and second thing, perfect pair should not repeat. Should not repeat. Are you getting my point? One, the perfect pair and perfect pair should not repeat. It is not, this is not perfect pair. This is not perfect pair. This is not perfect pair. Now see, AB perfect pair, AC perfect pair, BC perfect pair, and perfect pair is not getting repeated. This form is optically active. Only one is optically active. This is optically active. How many of you got it? First of all, do let me know. They are optically inactive. These 4 are optically inactive. These 4 are optically inactive. If you are not able to understand, do let me know. I will tell you 100 times. I will tell you 100 times. Kids, is this really good? With the help of this, we have cleared our GI. We have cleared our OI also. Do let me know how is it. If you're really liking it, why the likes are not increased? Why less likes? Why not smashing the like button, kids? If you have not done that till now, smash the like button, kids. Now, out of those, if you want to know any other compound, do let me know. Out of these, any other compounds, OI, if you want to understand, do let me know out of these. So you must be interested in this. How many of you are really interested in this? 15 ones. See, 15 ones GI I have drawn here. Now see, 15 I have drawn. 15 I have drawn or not? The GI. Now see, in the first one, perfect pair, perfect pair, perfect pair, perfect, 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 all 15 are having what? All 15 are having what, kids? Do let me know. All 15 are having what? 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. All 15 are having perfect pair. All 15 are perfect pair, and all 15s will have their mirror image. So these 15 and those 15, they will be enantiomeric pairs. So if these are 15 dextro, there's 15 are levo, 15 and 50. There are total 30 optically active isomers. How many of you got it? Really liked it? First time, how many of you are able to understand it? Kids, do let me know. I want to see your reaction. Everyone do let me know, kids. How many of you got it? Really got it for the first time? I want to see green hearts along with some fire in the chat section. Do let me know, kids. How many of you are able to understand it for the first time? Thank you, kids. Thank you. Wow. Really great. Now, how many of you want to visualize it? How many of you are interested in visualizing it? How many of you want to visualize it? Now see, let me give you the visualization field. Visualization. Visualization. Now if I draw, suppose M, A, B, C, D, E, F. So I have written M, the central atom. Suppose I have written A, then F. Now what is left? We are left with B, C, D, E. Just see. If I cut vertical cut, if I put a vertical cut, see, if I put a vertical cut from here, I will be able to draw these atoms into equal part. But see, on the right hand side I am getting C, but if you see on the left hand side B, right hand side D, left hand side E, right hand side is not equal to left hand side. No plane of symmetry, no vertical plane of symmetry. Now if I cut it like this, suppose I have told you in a square planar complex, whatever the ligands you are going to keep on these four places, and if you cut it you will get plane of symmetry. But now it is octahedral. The upper part is different from lower part. If they would have been the same, what I have told you, perfect pair is required. If this is A, upper part is A and the lower part is also, it would have been A, then the plane of symmetry would have been there, because if you cut it like this, there will lie plane of symmetry, there will be plane of symmetry, the upper part will be like lower part, but there is A and here is up F. That's why I have told you that perfect pair is required. If this is A, this should not be A. If this is F, this should not be F. They should be different. Otherwise, if you cut, sandwich cut will be there, plane of symmetry will be there. How many of you got it? That it will never have neither vertical plane of symmetry nor sandwich nor diagonal. No plane of symmetry is present. No plane of symmetry is there. So it is declared to be optically active. How many of you got it, kids? Now in this way you will get organic chemistry isomerism also. This is the way that you can understand Mahalakshmi polymera. This is the way you can understand organic chemistry isomerism also. Now at least make 300 likes. What are you doing, kids? What's going on? Why not 300 likes? 292 only. Now after this, this is all clear. Now I will teach you hybridization, the CFT, each and everything, then the color theory you will understand. Are you ready? Show me green hearts if you're ready. The second part I am going to start with. This is all about first, the main part is we should know one thing, that is spectrochemical series. If we know the spectrochemical series, we can do anything. Chemical series. If we don't understand this series, if we don't have command over this series, we can't do anything. Now, do you want to know my trick? How many of you are interested in knowing the trick? Show me fire in the chat section if you want to know this spectrochemical series. The last line is of strong field ligands. Last line is of strong field ligands. Strong field ligands. All they are weak field ligands. The strong field ligand. Now, first part is how to learn it. How to learn it. Are you ready for it? If you are able to learn this spectrochemical series, then only anything else will start. Anything else will get started once you learn it. Now, I am going to give you the trick, but not easily. If you are not energetic, if you are not good in listening, you can't do anything. If you really want to know the trick, full on Josh, I want to see 305 likes are there, 140 or 50 people are watching. I want to see everyone's, any emoji should be there. Any emoji should be there. At least everyone has to put emoji, whatever the emoji. Sahana, see, Sahana has shown. Sri Nandini has shown. Everyone. If you're not showing it, I'm not going to give you a trick. I will directly teach. Structural isomerism is very different. No need to Go for it. It's very simple, structural isomerism. I'm going to tell you the toughest part, the tough portion which you can't do by yourself. What is the need of simple things? Baba is not made for teaching simple things. Okay, if you're not having emojis, you can write yes, sir. Anything you can write. Okay, okay. Now, see. Indian bro Sachin, everyone just repeat along with me. Indian bro Sachin, Indian bro Sachin's child Sara, Indian bro Sachin's child Sara, everyone just repeat along with me. Indian bro Sachin's child Sara, Indian bro Sachin's child name is Sara. Write down in the chat section. Indian bro Sachin's child Sara. Aharara. Indian bro Sachin's child Sara. If you don't know this spectrochemical series, you can't understand hybridization, you can't understand color, you can't do anything. Once you know this spectrochemical series, you can do all the questions without even my help. Everyone write down in the chat section. Indian bro Sachin's child Sara. Aharara. Everyone, if you're not writing, I'm not going to give you. I want to see your energy. Indian bro, the rhymes. Indian bro Sachin child Sara, la 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 la. Very good. Indian bro Sachin's child Sara. Everyone say, kids, study like that. No need of further revision is required. If you're not having good command on a spectrochemical series, you can't do anything. Indian bro Sachin child Sara. Okay. Indian bro Sachin child Sara. Very good. Indian bro Sachin's child Sara. Now see. Is fond of, Indian bro Sachin's child Sara is fond of oxalate, fond of oxalate in water. Oxalate, you pronunciate like omelette. Oxalate in water along with nachos. Oxalate in water along with nachos. Now see, it's very, very important. Here it is Sachin, ambidented ligand. See, ambidented ligand. Sachin, and this is nachos. Indian bro Sachin child Sara is fond of oxalate in water with nachos. Is fond of oxalate in water with nachos. Indian bro Sachin child Sara is fond of oxalate in water with nachos. Is fond of, very good, Mahalakshmi, very good. Indian bro Sachin child Sara is fond of oxalate in water with nachos. Okay, Jamesh, yes, but right now everyone, kids, I can't make you perfect in coordination chemistry, in color. No one can teach this chapter like your Baba HSP. No one can tell you this trick. First of all, at least you can say thanks to your Baba HSP. Baba HSP is making your coordination chemistry nalla eriku romba sulubham. The people who are thinking like coordination chemistry padikkaradu customer, I'm saying ella it's romba sulubham. I will make idiyappam murku things romba sulubham. What I'm saying, the toughest thing I'm going to make it easy. Right now I was speaking in Tamil. I don't know what was the pronunciation. Tamil people can tell me how was I speaking. Indian bro, you can rhyme, you can make rhyme, you can sing. Indian bro, such is child Sarah is fond of oxalating water with nachos, oxalating water with nachos. Thank you Deepak Raj, thank you Sana, thank you Lingesh. Wow, you made my day, you made my day, you made my day. And I will make your chemistry fantastic. Very good, Pabi. Yes. Money Brar, sir, your teaching style is very good. I really appreciate. Thank you, Money Brar. Thank you. Really, thanks. NCS is isothiocyanate. Wow, Harshraj. Whatever, my God, kids, really thank you. Thank you. Now I am so happy. I am so happy. I am so happy now. I will, Pavi, I will. Now see. Indian bros, Sachin child, Sara is fond of oxalating water with nachos. Now, educated Neha. Educated Neha, what I am going to write over here. See. Educated, EDTA. EDTA is educated Neha is teaching English. Educated Neha is teaching English in Canada and Colombia. Canada to Colombia. Once you read it out, once you keep it in your hippocampus, then only I can move ahead. If you're not able to keep it in your brain, we can't do anything. Indian bro, Sachin's child Sara is fond of oxalating water with nachos. Educated Neha is teaching English. Educated Neha teaching English. Canada to Colombia. Indian bro, Sachin's child Sara. Nara de Samara is fond of oxalating water with nachos. Educated Neha is teaching English. Canada to Colombia. Everyone sing this song. Make your day. Then only you can understand what I'm going to. First time you will see how I'm going to make hybridization clear, how I will make color theory clear. Salar Devarata, thank you kids. Write down this trick. Thank you, whatever, thank you. Indian bro, Sachin. Take this line. Indian bro, Sachin's child Sara, Nara de Samara, is fond of oxalating water with nachos. Educated Neha is teaching English. Canada to Colombia. Shuffle, strong field ligands. Vishal MH, very good. Now, once this is clear, once you got command over there, these are strong field ligands, they are weak field ligands. Strong field, this line is of strong field ligands. Now, once it is clear, now I am going to tell you one thing. Although oxalate and water being weak field ligands, although these two are being weak field ligands, but with cobalt 3 plus, remember that, with cobalt 3 plus, they will act as strong field ligand. What I'm saying, these two, water and oxalate, they are being weak field ligand, but with cobalt 3 plus they will act as strong field ligand. Let me write down this over here. What I'm saying kids, although water and oxalate are weak field ligand, but with cobalt 3 plus, remember that cobalt 3 plus will act as what? Strong field ligand. Remember this, these two ligands with cobalt 3 plus will act as strong field ligand. The first point, because if you can't remember this thing, you can't do anything. Now the second thing, remember that all ligands with 4D and 5D cations, metals will always act as strong field ligand. Will always act as strong field ligand. 2 points. After this, I am going to write down the third point. Okay. Third point is, first let me show you where is that. This ammonia. Although ammonia is what? Ammonia is strong field ligand, but it will act as weak field ligand with whom? Let me write down. Although, third point, ammonia is strong field ligand, but with coffee man nickel, always remember that 2 plus, they should have 2 plus, not 3 plus. With coffee man nickel, ammonia will act as weak field ligand. The coffee man nickel will make ammonia two-way WFL. Coffee man nickel will make WFL. Coffee man nickel, hey. Coffee man nickel 2 plus will make ammonia as WFL. Although ammonia is SFL with successful. Although ammonia is successful with others. Although ammonia is successful in stays strong field ligand. Although ammonia is successful, but with coffee man nickel in 2 plus oxidation state, it will get WFL, weak field. It will become WFL, WFL. You got it? Everyone just to let me know. Although ammonia although ammonia is successful, but coffee man nickel made it WFL. Oh, Boost Gaming, Baba, HSP made me love chemistry. Thank you. Although ammonia is successful, but coffee man nickel in 2 plus oxidation state make it WFL. Thank you, Sensei. Oh my God, number of people have become Baba HSP's fan. Oh, kids, number of kids are becoming Baba HSP's fan. Really? Okay. So before moving ahead, let me show you something that if you really want to get such type of things, what you are supposed to do. You can guide your juniors. Kids. If you really want that your juniors, your brothers, sisters, they should get this type of teaching, your juniors, classmates, relatives, or even sometime if you are in need of, then remember that Iconic and VIP week is on. Choose your agent NEET UG group of friends tonight. Use code HSP10. HSP10. Now, Iconic and VIP features, benefits, Unacademy, see Iconic, VIP, number of things are over there, kids. VIP features, all these are VIP features. You can see, kids, you can read it out. Number of features are there. NEET UG subscription pricing, C plus subscription 4,999 for 2 years. This is for 1 year, and you have to apply code. You can tell others to apply code. Which code? Code is HSP10. Remember, code is HSP10 without gap. It's really awesome. Just for rupees 9,999, they can get 2-year course, and thus for 5,000, even 1 rupee less, they can get 12 months. It's really cheapest one and the best when the quality is there. Kids. Quality wise, it's really very good. Now, Unacademy notes, you can see really it's awesome. These notes, for this you have to purchase for Iconic one. Now, plus Iconic and VIP features are there. Number of features are there. Can you see, kids? Now, spin and win crazy rewards, mentorship, earphone, this number of things, my dear friends. Really, it's awesome. And free mock test series before actual exam, and this is for you people only, kids. See the date, 20th April, 2 to 5 p.m. Enroll right now. You can put code, it is free of cost, HSP10 kids. It's really awesome. Free mock test. See, it's free. Apply HSP10 over there. You will get free of cost. No charges are there. It is just free of cost, kids. Now, join NCERT Crux test series for NEET UG. And right now, once again, I will tell you, put code HSP10 without any gap. Now, test flow is given over there. You can go with that. Join Nimbus batch for NEET UG by Team Titans, the best team, Seep ma'am is there. Akanksha ma'am is there, Sir is there for physics, Seep ma'am for bio, Akanksha Kanwal ma'am for chemistry. The best team. This is really the best team. You can go with that. Join Nimbus batch. April onwards, and this team is for Nexus for 12th, that was for 11th. Phoenix batch, wow, really the fantastic teachers once again. Now all BIP NEET UG batch for just for rupees 44,999. Use code HSP10. Once again, HSP10, you can access to any batch. Now let's come back, kids. Now we were at this place. 3 points we have written. Till now it's okay, kids. Do let me know in the chat section. Till now is it okay? So that we can move ahead. Till now is it okay, kids? Thank you, Sahana. Thank you. Thank you very much. Thank you really very much. Break. Okay. Tally name is t.me HSPN t.me / HSPN. This is tally t.me HSPN, right? Now kids, let's go with this spectrochemical series. Okay, now right now you need break, or after some time should I give break? Okay, right now you need break or after some time? Do let me know in the chat section. Right now, after some time? 9:30. Okay, at 9:30 I will give you one break. Okay, now spectrochemical series, once it is clear, now I will give you the theory. I will give you the real feel of how to identify any color and how to find out any hybridization, any color. Let's go. Now see, first what you want? First, do you want to know the color theory or the hybridization? Valence bond theory, hybridization or color? What do you want first? What do you want first? First option, hybridization of any compound you want to understand. Second option, color of any compound. Color of any compound. What do you want to know? I will tell you both, but for preference wise, what do you want first? What's your preference? Let me see, one or two. For one, it's green hearts. For two, it's purple heart. Green heart or purple heart, I want to see. First, green hearts. I think green hearts, everyone is going for green hearts. See kids, whatever I'm doing, I'm asking. Whatever I'm doing, I'm asking at every moment of time. That's really fantastic. So let's go with preference wise. First, let's go with hybridization. Let's see hybridization. hybridization. Now see, if I am provided with compound K4FeCN6, now how to find out hybridization? Everything, each and everything I will tell you. I will tell you each and everything, right? Are you ready with full brain? See, there is iron. Just focus on the central metal atom or ion. This is your central metal atom or ion, right? Now take it out, write it over here. Now if they have given you its atomic number, then it's nalla iruku, romba sulvam, means very good. But if their atomic number is not being provided, then there is problem. So how to get its atomic number? This is 26, but if any element's atomic number, if you are unable to find out, what you should do in that condition, that see to it. Remember what I'm saying. What I'm singing, what I'm going to tell you, just see. Fourth class ka, this is S block, leave it. This is fourth period, S block. Fourth class ka science teacher, very crazy man. Everyone say, fourth class ka science teacher, very crazy man. Fourth class ka science teacher, very crazy man. First of all, say this much in the chat section, then I will complete it with that accent. Science teacher, very crazy man. Hey, hey. Science teacher, very crazy man. Hey, hey. Science teacher, very crazy man. Science teacher, very crazy man. Science teacher, very crazy man. Let me see what you're saying. Are you singing or not? Science teacher, very crazy man. Felt cold in night with cousin. Alex Plessy, everyone is able to hear me. No, voice is clear, kids. Do let me know. Am I clearly audible and visible? Science teacher, very crazy man. Now, felt cold in night with cousin. 26, 27, 28, 29, 30. Now, once you are able to understand this, I will tell you how to write down the electronic configuration also in just 1 second, so that whatever they are going to ask, how many number of unpaired electrons, what is the Bohr magneton, whether it is hyperlegated, hypolegated, I will tell you each and everything. High spin, low spin, each and everything. But everyone write down this song, this mnemonic. Science teacher, very crazy man, felt cold in night with cousin. Felt cold in night with cousin. Science teacher, very crazy man, felt cold in night with cousin. Felt cold in night with cousin. Now see how to write down the electronic configuration. First of all, I will write down on the next page, then I will write down the electronic configuration. Fourth period, potassium, calcium. Otherwise, I know very clearly potassium, calcium, scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. You can go like this also. If you don't want to remember the mnemonic, science teacher, very crazy man, felt cold and night with cousin. If you don't want to go like this, potassium, calcium, scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. Now, see how to write down its configuration. First, write down the atomic number. It was 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Now, reverse it. Reverse it. Suppose you want to write down this one. So, reverse of it, 3, 2. So 3d3, 4s2. Now if you want to write down for iron, reverse it, 26, so 62, 3d6, 4s2. Anyone, this is exceptional, leave it. Nickel, 28, so write down 82, reverse it, 3d8, 4s2. Now no need to write down the whole electronic configuration in this way. You can simply write down the electronic configuration. Is it clear? Within seconds. Do let me know in the chat section. As early you are reaching to the electronic configuration within fraction of seconds, it will become really easy. It will become really simple. Do let me know. Is this much clear? Science teacher, very crazy man, felt cold in night with cousin, potassium, calcium, scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. In this way, just reverse the atomic number and then you can write down within fraction of seconds. Is it clear? Do let me know in the chat section, kids. Kids, this all I am doing for you just to make it easy peasy lemon squeezy. Yeah, it's clear. Now see. Now let's go back. Now it's over here. And kids, don't write anything else in the chat section. You know that some people are spamming. So I want to say to them, where is the time to hate when there is so little time to love? Your chemistry. Where is the time to hate when there is so little time to love? Kids, cool, remain cool. While studying, you can hear the music, listen to music. Oh, thank you, Vishal. Yeah. Where is the time to hate when there's so little time to love? Your chemistry. Okay, now let's come back. Thank you, kids. Thank you. Now see. Iron is 26. I will reverse it. Then on reversing, I will get 62. Now 62, 3d6 and 4s2. This much I have done. Now your target, the second step is how to write down the electronic configuration for iron. Just find out its oxidation number. This was the first step. Second step, oxidation number. How to find out oxidation number? See, 4. It's written 4. So 1 into 4. This one X plus 1 cyanide is having 1 negative charge. So 6 into minus 1 and the compound is neutral. So 0. How much the value of X will come? 4 plus X minus 6 is equal to 0. So X is equal to plus 2. So it is ferrous. I will write down it's a ferrous Fe2 plus. So 2 electrons will go from their outermost orbit. It is outermost. Now it will become 3d6 4s0. Now 3d6 is like this. One, two, three, four, five, 6. But this is free cation. This is the configuration for free cation. But you see, this ligand cyanide is strong field ligand or weak field ligand? Do let me know. Under the influence of this ligand, strong field ligand or weak field ligand? Your cyanide is strong field ligand. You know cyanide. Indian bros such as child Sarah, yes, is fond of oxalate in water with nachos. Educated Neha teaching English, Canada to Colombia. Do let me know in the chat section. Strong field ligand or weak field? Strong field ligand. This strong field ligand will say, hey, just shift. It will apply force. Just move. Hey, you, not listening. Just go. You go away over there. You just go away over there. Wow, fission, repulsion, applying force. They got shifted. Under the influence of strong field ligand, they got shifted toward this side. Now, it will be like this. Under the influence of strong field, they got shifted over here. 6 electrons. Now this is free. This is 3D. Now one cyanide donates 1 lone pair. It's a nucleophile. One cyanide donates 1 lone pair. 1 lone pair electrons. So see, this cyanide is having how many lone pairs? 6 cyanides are having how many lone pairs? 6 cyanides are having 6 lone pairs. So it will start filling from here. It will start filling from here in 3D. Now let me draw it on the next page so that you can understand. Each and everything. Just see. (3D), 4s, 4p, 3D, 4s, 4p, 3D, 4s, 4s, 4p, 4D, right? Now see, I have told you that it has shifted 6 electrons of iron. These are the electrons of iron. Now, cyanide's electron, 6 cyanide's electrons will be over here. 6 lone pair, 1, 2, 3, 4, 5, 6. So D2sp3, this is the hybridization. Now which D is involved? 3D. This is 3D. 3D is involved and 4D is empty. 4D, that outer one is empty. Now the inner D is involved, so it is inner D. Inner D means they are 4s, 4p, then inner to it, that's why it is inner orbital complex. Now see, electrons got paired up electrons, so low spin complex, and this has acting as cyanide has shifted as hyperligated complex. And remember that no unpaired electrons, so the value of n is 0, so under root n into n plus 2 Bohr magneton, the value of this will come 0, so it is dimagnetic, not paramagnetic, it is being dimagnetic. How many of you got it, this thing? Do let me know in the chat section if it is clear to each and every one of you. Sahana, clear? Everyone, just to let me know how many of you got it. Really, you got the feel of it. Everyone, just to let me know if you got the feel of it. And if the same compound would have been like this, just see. If the compound would have been given like this, just see. If the same compound would have been given like this, K4 FeCl6. Now see, once again I will write down iron 26, I will write down 62, so 3d6, 4s2, I will find out the oxidation state, 4 into 1. Are you getting my point? Why 4? Potassium can donate only 1 electron. 4 into 1 plus x minus 6 is equal to 0. So x is equal to plus 2. So I will write down iron as plus 2. Then I will write down 2 electrons gone, 3d6, 4s0. So I will write down like this. Now see kids, chloride 1, 2, 3, 4, 5, 6. Now chloride is strong field ligand or weak field ligand? Chloride is weak field ligand. Now weak field ligand cannot shift this electron, they will remain over there. Now the filling of 6 lone pairs will take place from here. That means this is 4s. Now how the filling will take place, let me show you over here. 4s, 4p, 4d, s, p, D, C. Filling will take place here. S, 4S, 4P, now 4D. So the hybridization changed. SP3D2. SP3D2 means D is involved of 4, not of 3. 3D is over here. So outer orbital complex now they are free electrons, high spin. Okay, hypoligated. Now how many unpaired electrons are there? 1, 2, 3, 4. So 4 unpaired electrons. So the value of n is equal to 4. 4 unpaired electrons. So Bohr magneton will be under root n into n plus 2, that is square root of 4 into 4 plus 2, 4 plus 2, 6, 2 is 24, square root of 24. Now no need to go for this, write something more than 4 because 5 5s are 25. So 4.9 something, right? Approximately near to 5. Got it, kids? Kids, how many of you got it? Really, you got it? How many foot? This is clear, really clear. Do let me know, kids. Do let me know. How many of you have enjoyed it? Do let me know. Break, yes. Now it's dinner break. Let's meet at because we need to do dinner. Really, you are enjoying, everyone is enjoying. So what time, at what time we are going to meet? Let's take a dinner break. At what time we are supposed to meet, kids? Let's say 10:15. 10:15. Let's meet at 10:15. It's a dinner break. Okay, kids, but come with full on energy. Come with full on energy. Make a promise that you will come with full on energy. I will show you the magic of chemistry. I will show you the magic of chemistry, kids. It's my promise. Really, it's a promise. Really, it's going to be a promise, right? Okay. Welcome back, kids. Just to let me know, are you back with full on ATBs? Are you awake? Everyone, just to let me know. I want to see with full of energy. Lena is saying, yeah, full on energy. I want to see, kids, that everyone is with full on energy. How's the Josh? I want to see in the form of some fire in the chat section if the Josh is really very high. Now, after teaching you hybridization, I will teach you how to find out color. But just to let me know, kids, make it 400. Why it's 380? Kids. Why it's just 380? Smash the like button. If I have not till now smashed it, make it 400. Oh, what's going on? P block, I will tell you after this. First, let's go with the sequence. Right now, it's a time for color. Once the color is over, I will tell you Werner's coordination theory, Werner's theory, the father of coordination theory, Werner. Then I will tell you DNF, the main part, the tough part, okay, where you are getting stuck. And then P block, okay. So, everyone, do let me know, are you back? We are going to start with what? The color theory. Hybridization is over. Now let me tell you the color theory. Everyone ready for the color? Just to let me know, kids. Is everyone ready for the color? Color. Color. My dear students, I am going to tell you about the color. Is everyone ready for the color? Just to let me know. I am going to tell you about the color. How to find out the color of any complex compound. Just to understand the color, what color the compound will show, we should know three parts. Three things we should know. We should have knowledge of these three things. First thing is, we should know color wheel. Color wheel, we should have knowledge of color wheel. I will tell you right now the color wheel. Second thing, the oxidation state. Oxidation state of central metal, ion or atom. And third thing, the knowledge of spectrochemical series. Chemical series. These three things, if you are having in your brain, then definitely you can understand. Definitely you can get the answer to your questions. Now, are you ready for this? Is everyone ready? Let me see that. Is everyone ready? I want to see some fire in the chat section if everyone is ready. If you're ready, then I want to see some fire in the chat section. How's the Josh? That your fire symbol will show the Josh. Structural isomerism, okay. Sahana is saying, sir, Baba, please teach structural isomerism also. So I will tell you structural. That is the easy part. That is easiest, but yeah, I will tell you structural, how to find out structural isomers also, okay. So, where is the Josh? I cannot see the Josh. Where the fire symbol is. Harni ready, Sahana. Okay. Sahana is saying, it's easy, but we want to learn it from you. Okay, I will tell you. That's okay. Fine. Fantastic. I can see in the chat section that what you want. That's really awesome. Boost Gaming, Sahana, Yaditi, Nomenclature also. I will tell you nomenclature also. Don't worry. Baba will take care of each and everything. Don't worry, kids. Don't worry. Okay. But call everyone. Why the people? Am I not teaching good? My teaching is not good. If it is good, call everyone. All of you call everyone, then I will teach P block also. 150 students are watching right now. Make them 250. Make them 250. Let's see whether you can do that or not. Call your friends. Everyone call your friends. Let's see, can you make it 300, 250 or not? Everyone call your friends right now. Go and call your friends. Everyone put it in Telegram that yes, so awesome teaching is going on. Baba is going to teach color theory. Why they are not there? Baba, competition will decrease. Prach already know the competition will not decrease with your friends. No, not at all. Wow, that's really 150 now. Make it 200 at least. Make it 200 at least. 156. At least, let's see what you can do. Can you increase the number? Let's see. Now, let's see. Color wheel. First, let me tell you the color wheel. Color wheel. Make a circle. Make a circle. It's a circle, right? Divide it into parts. Always in your brain, divide it like this. Divide it. Have you done this much? Everyone, just to let me know, have you done this much? Now, remember that if I go like this, the energy is increasing. If I write here violet or indigo or purple color, purple, they mean same. VIP, just like your VIP badge, just like your VIP badge, this is VIP with maximum energy. What? Maximum energy. Maximum energy means least wavelength. Least wavelength. Am I right? Least wavelength, maximum energy. And if I read over here red color, red is maximum wavelength, least energy. Am I right? Now you are supposed to make the whole Vibgyor, violet, the blue over here, blue color, and adjacent to it complementary color is orange color. Orange color is the complementary color. Orange, it is orange. And to violet, it's yellow, complementary color. Here green, and the green is complementary to whom? Red color. Green is complementary color to green. Are you getting my point, kids? Green and red, they are complementary. Blue and orange, they are complementary. And these are complementary colors. Can you see, kids? First of all, do let me know these are complementary colors to each other. So energy is increasing, right? This, and you can divide it into two parts, east side and west side. The right hand side are of low energy colors, and the left hand side are just to let me know what I'm talking about. Left hand side are more energetic colors, right? More energetic colors. Complementary color is clear, complementary. Blue is complementary to orange. VIP is complementary to yellow, yellow is complementary to VIP, green is complementary to red, red is complementary to green. This much is there in your brain. Has it gone to your brain? Just to let me know the color wheel. The color wheel is in your brain, then only you can understand color wheel. Now, remember that what I want to say, that if you are having more oxidation state elements, more oxidation state and strong field ligand, more oxidation state and strong field ligand, then which light will be absorbed? Remember that absorbed light will be of high energy. High energy. Why high energy? Because if these two things are there, more crystal field splitting will be there. More crystal field splitting, they will cause more crystal field splitting, and due to this the absorbed light will be of high energy. So the emitted light will be of, emitted is something else. Emitted means what our eyes can see. Our eyes, the color E for eyes will see, will be of low energy, will be of low energy. Emitted will be of once again I am saying, if more oxidation state and strong field ligand, then this area light will be absorbed and that area light will be emitted. And on the other hand, if I write down like low oxidation state, weak field ligand, low energy light, low energy light will be absorbed, then which color energy will be emitted? Emitted, E for eyes, E for emitted. Remember that emitted energy. Now the eyes can, the eyes which can see, the eyes, the light which can be seen by means the light which can be seen by eyes, our eyes can see, emitted will be of high energy. High energy, right? If somebody is absorbing this area light, will show that color. If absorbing that area light, will show this side light. Are you getting my point? For example, if I write down K4FeCN6, if I write down compound K4, or better than this, if I write down cobalt cyanide whole 6 3 negative. Can you tell me what is the oxidation state on cobalt? Find out oxidation state. X minus 6 is equal to minus 3. So the oxidation state on cobalt is plus 3. Plus 3 is high oxidation state and cyanide is strong field ligand. Strong field ligand, high oxidation state. Strong field ligand and more oxidation state means this color will be absorbed. This color is, you can say violet, VIP, violet, indigo, purple. So this is absorbed color. So which color it will emit out? It will emit out the yellow color or light yellow color. Light yellow or yellow color it will emit. Light yellow or yellow color it will emit. Are you getting my point? if I say any compound is like nickel, NiH2O whole 6 2 plus. Now see, low oxidation state, nickel is with 2 oxidation state. This is lower oxidation state, and water is weak field ligand. So which is least energetic light? It will absorb red color light. Red will be absorbed and it will emit out this area light green color. So this compound will look like green. It will emit out green color. So what is the color of that compound? Green. What is the color of this compound? Yellow. It is yellow in color. Now see, this is telling us each and everything about the color. No one can tell you such a great theory. Do let me know in the chat section how many of you understood. Really something great. How many of you got it? How many of you really understood? I can write down any color, any color, any color. If you really got it, just do let me know, kids. Wow, thank you, Sahana. Harni Reddy, thank you. Thank you, everyone. Now, you can find out any color, any color. Let me write down at least all NCERT colors. Should I write down? You check NCERT. I will write down all the colors, whatever is given in NCERT. You check your NCERT, right? Everyone just check your NCERT. I will write down the color of each and every compound. Just see. Absorbed, emitted. Absorbed, emitted. Okay. Now absorbed color is UV or violet, light yellow to yellow. Check in your NCERT. Everyone check in your NCERT. You will say that, yes, Baba, you are like God. You will say like that. I am not saying. Cobalt, ammonia. With ammonia, cobalt is strong field ligand. 3 positive. So it will absorb blue color and will look like blue, orange. Orange color. It will emit out orange color. Cobalt, ammonia, 5 water. Water is also acting as strong field ligand with this. So blue, blue green will give you red color. Red color, it will look like red. Check your NCERT or Tamil Nadu board, whatever the board you are having. Cobalt, ammonia whole 5, 1 weak field ligand like this. So 0, 1 negative will go to that side, positive, so 2 plus. It will absorb at the border light yellow and will emit out purple color. Purple can be given over there, violet can be given over there, indigo can be given over there, right? Like this. Now, if I write down nickel H2O whole 6 2 plus, so it will absorb red color and red, so it will look like light blue or green, light blue green color. Now if I write down one strong field ligand like nickel H2O whole 4 and En, so it is little bit, so it will absorb orange color or on the boundary line of orange and red, so light blue color. Once again light blue, and that was green, more green, and this is light blue. You can see it's on the right hand page in NCERT. Nickel H2O whole twice only and En2 2 plus, then it is more, so orange, it will absorb oranges, yellow, so it will look like somewhat in between blue and purple, whatever is there. And suppose if I write down all nickel H2O, so no H2O, all En3, so it will absorb a light yellow and it will look like violet color. Now check out your NCERT, all the colors are getting matched or not, all colors are matching or not. Do let me know in the chat section if you are having NCERT. Just check it out, everyone, just check it out, your NCERT. Now you will say yes sir. Do let me know, kids. Then you will say yes sir, really you are awesome. You have to say that yes sir, you are awesome. Sahana, thank you everyone. Let me show you whatever I have shown you. Let me show you if you can see what to write. Coordination chemistry, NCERT. Just see, is it visible to all of you? Is it visible? If yes, see CO, COCN6, ultraviolet, light yellow, it's looking like light yellow, see. Then CO, ammonia whole 6, blue, and it's looking like yellow orange, as I have told you. Cobalt ammonia, water, blue green, looking like red. Cobalt chloride ammonia, yellow, looking like violet. See the slide, it's matching or not. If yes, I want to see number of green hearts. Do let me know, kids. If it is really matching, kids, I want to see number of green hearts, red hearts. Let me see in the chat. You check it out. What the thing I have told you, you have to follow that. That will show you yes. Whatever the things I have told you, follow that. I want to see fire in the chat section if you are really able to understand it, kids. Then I will give questions based on this. Now, let me show you another page. Just see to it. See, these colors I have shown you. Nickel H2O, just see to it. If you can see, nickel H2O whole 6 green, nickel H2O whole 4 En, aqueous light blue, nickel H2O, it should be misprinting, it's misprinting, it should be 2. See, misprinting, even misprinting is given. And nickel En whole 3 2 plus, it's purple. Here is the misprinting, kids. This should be 2, misprinting, because here 4, here 2, no water is there, and it's purple. Can you see? I hope that it's clear to each and everyone. Now let's move on. Now color is clear to all of you. Color theory is clear. Now let me show you, as Sahana has said, sir, tell us about something about structural isomerism. So let me tell you structural isomerism. Structural isomerism. Just see structural isomerism. Ready? Structural isomerism. Ready, everyone? Is everyone ready? Just to let me know, kids. Is everyone ready? Then I will start giving questions. You will really feel, wow, really awesome. Kids, do let me know how is the Josh. Structural isomerism. Just see. First of all, linkage isomerism. Linkage is different. Like if I say K4 Fe NO2 whole 6. Now if I write down K4 Fe ONO whole 6, so the linkage got changed. Here nitrogen is forming a bond with central metal atom, and here oxygen, so they are linkage got changed. So linkage isomerism. I hope everyone got it. Here nitrogen is donor, here oxygen is donor, so the linkage got changed. Linkage got changed. Now second one is ionization isomerism. Ionization. Now if I write down cobalt, ammonia whole 6, but better to write down cobalt, ammonia whole 4, Br2 Cl, and write down another compound cobalt, ammonia whole 4 BrCl, and one Br has gone over there. Now if you treat it with AgNO3, silver nitrate, what PPT you will get? See, this is primary valency. If you see Werner's coordination theory, this is ionizable. And these are non-ionizable valencies. So these are known as secondary valencies, and this is known as primary valency. Here this is ionizable primary valencies, and this is secondary valencies. So with AgNO3 you will get white PPT of AgCl, white PPT. But here with AgNO3 you will not get white PPT, you will get AgBr, light yellow PPT. Are you getting my point? You will get AgBr, light yellow PPT. So here the ionization part is different. The one which can ionize, their molecular formula is same, but the structural formula is different. Are you getting my point, kids? Do let me know everyone is getting my point. Now coordination isomerism. Coordination isomerism, if I say coordination isomerism, just see to it. If I write down Ag ammonia whole twice, and if I write down cobalt Cl2, now if this is getting changed, that Ag is forming bond with Cl2 and cobalt is forming bond with ammonia. So they have just changed their houses. Here Ag was bonded with ammonia and here Ag is bonded with chloride. So coordination sphere got changed. So they are very simple. This very simple, very simple. Kids, you got it or not? Just to let me know. Everyone got it? Is it clear to each and everyone now? Once it is clear, I will move through questions. I will move through questions and I will show you each and everything, kids, whatever I taught you, because now kids can't wait more. Kids are not having that much of time now. See, whatever I taught you, just see over here that Cl3 ammonia, it is giving 3 moles of AgCl. Werner's coordination theory, it is giving 2 mole, it is giving 1 mole. So how the structure can be written? You see, its structure will be like CO ammonia whole 6 and then 3 chlorides are outside. That's why you're getting 3 moles of AgCl. And if I say that it's giving 1 mole, so I will write down CO ammonia whole 4 and Cl2 inside and 1 Cl outside, 1 Cl outside. This is Werner's coordination theory. 3 primary valencies are there which can ionize only 1 ionizable valency. So based on this, let's do the question. This I have told you. Now based on this, see, this is question. Just go for the question. Are you ready for the questions? Do let me know. Are you ready? I've told you each and everything. Show me some fire in the chat section if you're ready for the questions. If you're ready for the questions, do let me know in the chat section, kids, that you are ready. Ready for the questions. Show me some fire in the chat section if you're ready. Okay. So let's it go. On your screen, I'm going to start the questions here. What's the answer? Let me see in the chat section. I'm sitting in front of screen. Okay. Do let me know what's the answer. Do let me know what's the answer, kids. You will go for which answer? B. Everyone is going for B. Let me check it out. Hey, computer. Then what's the answer? This 3 chlorides outside. Here 2 chlorides. Here 1 chloride. So 3, 2, 1. 3, 2, 1. 3, 2, 1. B is the correct answer. Congratulations. Oh. 3, 1, 3, 1, 2. The correct order of the stoichiometric HgCl formed by energy treated with complex COCl3, 3, COCl3, 5 ammonia. Okay, 5 ammonia. Yeah, this is the correct answer. Everyone just see. If we talk about this one, CO, then 6 coordination number, that means ammonia 5, 1 Cl inside, 2 Cl outside. Oh no, 2 Cl, so 2 should be there, 2, and here only 4, 1. Wrong answer. This is wrong. It's B is the correct answer. B is the correct answer. Now see, kids, you got misprinting over here also. See, kids, that was wrong answer given. Are you liking it? Your confidence is more. Baba, solvent isomerism. Solvent will get changed. Sahana, the water solvent will come inside. That is solvent isomerism. The solvent water will come inside. That is the exchange. Kids, got it? Suraj, CFT. I will teach. Don't worry. Suraj, I will tell you about CFT in the questions. Okay. Now everyone, that was really awesome. Now next question, let me see in the chat section what answer you are going to give. Let me see in the chat section what answer you people are going to give. Fast, quick, kids, quick. D, some kids are saying D. Let me check it out. Cobalt-3 chloride forms several octahedral complexes with ammonia. Which of the following will not give test of chloride ion? Now see how to do it. Always remember that its coordination number is 6. See, let me teach you. Coordination number 6. We have to manage this 6. So see, first preference should be with cobalt. First preference should be given to preference. Remember that preference will be given to neutral ligand. All neutral ligand will come first. All neutral ligand. So in the first 4 ammonia 4 I have to write. Now 4 is this 2 chlorides, so it's completed 6. So 1 chloride, so it is ionizable. Now see 3, 5 will give. If you see this one if you see cobalt, ammonia only 3, so 3 chlorides should come inside. Now no chloride outside, no ionizable valency. See, there is no ionizable valency. So this is our answer. 4th, D is the correct answer. Let's see, kids are going for D. D is the correct answer. Congratulations. Now some important terms. Coordination entity, central metal atom ion. Already I have told you ligand. See the theory. I have come up with theory, isomerism, each and everything. Now let's go with the question. Whatever I taught you, will go with the questions. Okay, IUPAC. See, some kids were saying about IUPAC. Just go for it and then I will tell you what's the correct answer for this IUPAC. Okay. Everyone, just to let me know. Fast, kids, fast. What should be the correct answer? Fast. D. Krituk is very sincere student. I think Harni also going for D. Some are going for B. Okay, let me tell you first of all how to do questions. If compound is like K4 Fe CN whole 6, one compound, and another compound like CO ammonia whole 6 Cl3. What's the difference in between two compounds? Just see here, this is cationic part and this is being anionic part. Here this is cationic complex, this is cationic, and that is anionic. Remember that whenever this is anionic, central metal atoms name plus 8 will add over there. 8 will be there, and this will be simple names. Classmate, you can remember classmate. If this is coming anion, remember anionic part, then classmate. If complex is anionic, then classmate. If complex is anionic, then classmate. Will you remember this trick? If complex is anionic, then central metal atom, and at the central metal atoms and 8, add 8. Now see, this is having negative charge, so this is anionic part. Am I right? It's being anionic, so central metal atom, then 8 to this. Now see, what's the oxidation state? X minus 6 is equal to minus 3. So X is equal to plus 3. So name will be hexacyanido, no iron, hexacyanido, ferrate 3, ferrate, classmate. So it should be D. So kids, If your answer is found to be correct, show green hearts for yourself. If your answer is correct, show green hearts for yourself. And how's the trick? How is the trick? If central metal atom, this complex is anionic, if the complex is anionic, then classmate add 8 after the name central metal, Cm will become 8. Now IUPAC name of this compound. See, as I have told you, let's see how many of you can do this. Fast kids, fast. Do let me know, fast. Everyone, fast. Fast mode, just fast. Make it fast, kids. Do let me know. Quick, kids. Karthik, Kritik is really awesome. Let's see. CRF2. En, bis, ethylene diamine, difluoro, and chromium, what should be the oxidation state? X -2 plus 0 -1. So minus plus, it will become +3. So bis is not included in the alphabetical order. Remember that in complex chemistry, bis is not included in alphabetical order. Remember that. So who will come first? Ethylene diamine or that chlorido is outside? This will not written in the IUPAC mem, will not be written. So chlorido wrong, difluorido, bis, ethylene diamine, chromium 3 chloride. This should be the correct answer. Let's see. C is the correct answer. Yeah. How many of you got it done correctly? Show me green hearts, kids. Increase your energy level if your answer is correct. Fast, kids. What are you doing? Really good questions. Show green hearts if you're liking the questions. If your answer is correct. It's, yeah, how is the energy level? Very good. You should feel proud of yourself. This is the way to live your life. This is the way to win the examination, to get rank in your examination. Isomerism. See, I have taught you isomerism, structural, coordination, ionization, solvate isomerism. This form of isomerism is known as hydrate isomerism. As I told you, water molecules will get exchanged. Just see, if you see here 6 water molecules. Sahana, you asked me about hydrate isomerism. You asked me, now 6 water are inside, and now see 1 water has gone outside. Can you see, Sahana? Just to let me know, Sahana. You asked me about hydrate isomerism. You got it? Got it? Understood? Very good. Now, see, everything is there. And the complex, this and this, see, what type of isomerism? Let me see the answer in the chat. What answer you people are going to give? Fast, kids, fast. C is coordination isomerism. Sensem, yes, answer is correct. Let me bring 1 glass of water. Just a second, kids. Let me bring a glass of water. I'm back, kids. Okay, now see another question. Geometrical isomerism. I have taught you each and everything. See the notes and let me see the questions. This you can do, everyone. Easy question. So see, this is the compound PT, PY, ammonia, BrCl. All four are different. All four are different. M, A, B, C, D. Have I told you? Have I taught you? Give the answer. I want to see the answer in the chat. I've told you this thing. 4, no, no, no one was, no. 4 ligands are different. Then how many GI? 3 GI. Very good. Sahana is correct. Sahana is absolutely correct. 3 will be the correct answer. I taught you this thing. I've shown you this. I've shown you this. And this is anti-cancer species. Remember that 2-chloride. Okay, that is different one. This is different one. Now, valence bond theory. Oh, see. Now you can feel proud of Baba HSP. You will feel, you will say yes. Now do let me know what's the answer. What's the answer, everyone? Kritik D. Let me check it out. Fantastic, fantastic, Kritik. Now, these are easy questions you can do with the help of valence bond theory. We have gone through it. We have gone through it. Each and everything done and dusted. Done and dusted, kids. Now let's come to D block. It's completed, kids. All the questions we have done, each and everything we have done. Now, kids, before I move towards D block, one thing is left, crystal field theory. One kid was asking about crystal field theory. Let me complete that, crystal field theory, and then I will come to D block, right, kids? One thing is left here, and that is crystal field theory, right, kids? CFT is left. Am I right, kids? Sahana, do let me know. Other kids, everyone, do let me know. One thing is left, CFT, crystal field theory, which holds a hell lot of weightage. CFT is left. What is this? Crystal field theory. It also holds a hell lot of weightage, so we should know the crystal field theory, everyone. Just see to it. Before, because it will play important role in D block and F block also. It is going to play important role in D and F block also. Just see, if I say that I am being provided with octahedral complex, octahedral. So CFT in octahedral, CFT in octahedral. Just see, just to understand CFT in octahedral, we should understand one thing, that in atomic structure you must have studied this. That we are having x-axis, we are having y-axis, we are having z-axis, and like dx square, y square and z square. Just see to it, kids. Everyone just see to it. If I draw it like this, if I draw it like this, if I draw it like this. So if I draw dxy, this is x-axis, this is y-axis, then dxy will lie over here in between x and y axis. If I say this is yz, then dyz will lie over here in between. If I say this is xz, then they will lie over here in between the axis, the double dumbbell shape like this, double dumbbell shape like this. Am I right, kids? But if I talk about this is x-axis, this is y-axis, and if I draw dxy, then dx square y square will lie on the axis, dx square y square will lie on the axis. Are you getting my point? The lobes are directly pointed on the axis, towards the axis. They are directly pointing like this, kids. Are you getting my point? And if I draw dz square will lie like this, dz square, and it's fused like this, and this is one, you can say here, conical, two conical nodes, and this is being dz square. Dz square is like this, dz square is like this. Can you see, kids? So dz square, this is being dz square, dz square, dx square, y square. Can you see, kids? Dx square, y square, and this is d z square, dz square. They are directly lying on the axis. Lobes are directly lying on the axis. Lobes are directly on the axis. And here lobes are in between axis. Can you understand, kids? If you can't understand this, you can't understand anything. They are in between the axis. Do let me know with the green hearts in the chat section if you can get it, otherwise fire if you can't get it. This is from atomic structure. This should be clear to understand crystal field theory, otherwise you can't understand crystal field theory. This much is clear. If this much is clear, then only I can move towards. Do let me know. Fast kids, fast. Yeah, that's really fantastic. Now see, once it is clear, now let's see. If I draw octahedral, octahedral is something like this. Octahedral is something like this. This. Now, here is the central metal atom. Central metal atom, the ligand number 1. This is the way from which, okay, ligands approach I will tell you later on. First let me tell you where is D block. So if I try to draw, if I say this is x-axis, this one is x-axis, and if I say this is y-axis and this one is z-axis, right? X-axis, y-axis, z-axis. This is x. Let me change the color so that you can understand. This is x-axis, this is y-axis, and this one is z-axis. Okay, x, y, z-axis. That means where the electrons of central metal atom are located. Now tell me, this is the way from which ligand is coming from. Ligand is coming with its electrons, lone pairs. Ligands are coming from by its electrons, lone pairs. Electrons carry negative charge. All electrons are having negative charge. Now this is central metal atom, and it's these orbitals who are directly pointing on the axis. See whose lobes, these lobes, where it has gone. These lobes are directly pointing on the axis. That means this green and this red one, they are directly located on these axes. They are directly located. So who will feel more repulsion? Which will feel? So see kids, if I draw the 5 orbitals like this, then you must have studied in atomic structure. These one are known as T2G, these three are known as T2G, and those two are known as what? These two are known as EG, T2G, EG, and EG is dx square, y square, and dz square. They are feeling more repulsion. They are getting more repulsive forces, more repulsion. Why they are getting more repulsion? Because they are colliding with the ligand. They are directly on the path of ligand, directly located in the path of ligand. Am I right, kids? Am I right? And these are getting less repulsion, so their energy will increase. Energy will increase of EG. I hope got it. You got it. Now, how many of it got it? How many, if you really got it, just to let me know. And that's why it will be like this. The 5, they are all together. Now if I say in this way, energy is increasing, this energy level is increasing like this. 5 all together, then 5 got with more energy, and then degeneration has taken place. This has gone upper side, EG, and T2G has lost energy. So this is the energy level, my dear students. 1, 2, 3, 4, 5 orbitals. Right now also 5 orbitals with same energy. Now the bifurcation has taken place. This is with more energy and this is with less energy, and in the middle there is being barycenter. This is barycenter. Now let's see 4 orbitals. These are known as degeneracy because they all 4 brothers are degeneracy. All together same energy. This is energy is upper side, energy is increasing. Same energy till now they are having same energy, but under the influence of ligand their energy got increased, but still same energy. Now the bifurcation is there, so this is T2G dx square, y square, dz square. This is known as EG, and this dx, y, dy, z, dz, x, T2G energy decrease. Now these 2 got increased energy on behalf of these 3. So 3, that means upper side energy got increased by 0.6 dq, and the decreased energy is 0.4 dq. All right, this from barycenter 0.4, and this of octahedral splitting, got it? 6 dq 4 dq, 6 dq 4 dq. I hope everyone got it. Just to let me know in the chat section, everyone is able to understand or not. Very good, Shivans, Mind Training India. Everyone got it. And in tetrahedral it will get opposite. Tetrahedral will get opposite. Just remember one thing, that energy of tetrahedral will not increase that much because no one is coming in the path of ligand. If I talk about this crystal field splitting in tetrahedral, so remember that tetrahedral, this of tetrahedral splitting is 4 by 9 times that of octahedral, means less splitting is there. Why less splitting in tetrahedral? Less splitting. Why less splitting? Because no lobe is coming in direct path of ligand. So in this, if we talk about this is the energy increasing, upside energy is increasing. Now the order will get reversed. What reversed? All 5 together, then they with more energy. Now who will go up? This time T2G will go up and EG will go down, but D word will not be used because there is no symmetry. So T2 will go up and E will go down. So it is the order, kids. I hope that everyone got it. This will increase, this will decrease, reverse order. So now let me go with D block. Let's go with the D block. So see, each and everything I have completed, kids. We will start D block. Just to let me know in the chat section, is everyone ready for the D block? Is everyone ready for the D block? Everyone, just to let me know. Yeah, I will. Tomorrow we will do complete PYQ. Tomorrow, yes. Okay, metal carbonyl. Okay, I will tell you in D block. Metal carbonyls in D block. Now see, kids. Everyone just see. D block elements. This is not required. Melting point. Just remember, in melting point, if I talk about, there one question will come. Chromo-tungsten. Remember, these are at the top hill. Chromium, molybdenum, tungsten. The melting point is in this order. Remember that they are in 6th group. And they are having maximum number of unpaired electrons. That's why they're, what's the reason? Because of more number of unpaired electrons. Got it, kids? Unpaired electrons. More number of unpaired electrons, more the metallic bonding, and more is the melting point. And that's why if you see W, the filament of bulb is like this. Have you seen the filament of bulb? It's like W only, tungsten. 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 Pronunciation is tungsten. Alright. Now, variable oxidation state. This holds a hell lot of weightage. Very, very important. Let me tell you why. Only 3. Why these elements are doing like this? How many of you want to have the feel? Why it's like this? How many of you want to get the feel? Lingays, whatever, don't leave. How many of you really want to have feel of this? I will show you the feel. I will tell you why it's like this, kids. Okay, see. You want to have a seat. You want to get a seat in government college. Now these elements, their like motive is to have configuration like this: helium, neon, argon, krypton, xenon, radon. Now see, if I talk about 2, 10, 18, 36 D block element either want to become Yara or they want to become Kyara. Yara, Kyara. See, if I say that I am having element like scandium, its atomic number is 21. So 21 electrons. So if it wants to become like 36, it wants to gain electron. It has to gain electron. And it wants to become Yara, then it has to lose electrons. Why they want to become like them? Because they are noble gas configuration. These are having noble gas configuration. Now, if they want to gain electron, they have to react with ligands, and they will form which chemistry? They will form coordination chemistry, which we have studied right now. And if they want to lose electron, then how many electrons? 21, 18. 21 minus 18 is how much? 3. So scandium will lose 3 electron and scandium will become 3 plus. So it has got noble gas configuration. One point is clear. So if they are moving like this, we will say they are forming D block. We have to study D block, and that is coordination chemistry. Already completed D block. So this is the idea. Now once they are losing electron, like want to become Yara and Kyara, once they are losing these many electrons, see, science teacher, very crazy man, felt cold and night with cousin. So scandium lost 3 electrons, happy. Titanium will lose how many electrons? 4 electrons, 4 electrons. This will lose 3, 4, 5 electrons. This will lose 3, 4, 5, 6 electrons. This will lose 3, 4, 5, 6, 7. After losing these many electrons, they are thinking, why to lose these many electrons? Their effective nuclear charge, the nucleus is having proton that will keep on applying force of attraction on the outermost electron. So effective nuclear charge will increase. Effective nuclear charge will increase too much, so they can't donate those many electrons. Otherwise it could have donated 8 electrons, 9 electrons, 10 electrons to become Yara and Kyara, 11 electrons, 12 electrons. So this is not possible because of more effective nuclear charge. They are not going to lose that many. So this is maximum oxidation state. Now let me tell you, manganese, which oxidation state is more stable? Manganese plus 2 oxidation state and plus 7 is more stable, and chromium's plus 3 and plus 6. Now the question arises, why it's like that? Now see kids, why manganese plus 2 is more stable? That question will be asked, more stable. And another one, why big why chromium plus 3 is more stable? Just see to it, everyone, just see to it. Manganese is manganese, once again I would like to say, manganese is 25, so reverse it, 52, write down like this, 3d5 4s2. If it is losing 2 electrons, so become manganese 2 3d5. So you can see fully filled configuration, fully T2G Eg, you know, fully filled configuration over here. 1 electron, 1 more electron, 1 more electron, 1 more electron, 4, 1 more, 5, fully filled configuration. Got it? Now over here, chromium plus 3. Let me write down chromium's configuration. Chromium is 24, 3d5, 4s1. So chromium plus 3. So 1 from here, 2 from here, 3d3. Now it's T2G, you know, T2G and Eg was more energy. Now T2G is having 1, 2, 3 half filled stability of T2G. I hope everyone got it. Just see to it and let me know in the chat section. Everyone got it? Yeah, very good, Sahana. Everyone is able to understand, kids, to let me know. Everyone, just to let me know. You are getting it or not? Very good, very good. Okay, you want to say half filled? Yeah, fully filled like this, otherwise half filled. You are right. With respect to 5 electrons, what I was talking about, T2G and Eg, with respect to T2 and Eg I was saying, otherwise you can say half filled stability of d orbital. D orbital, you can say this also. With respect to T2G and Eg, I said both T2G and Eg are filled with single electrons. Got it? Let me see in the chat who has asked this question. Is it clear? I can't understand. Somebody has asked this question. Sahiti, I think Sahiti has asked this question. Sahiti, is it clear? Yeah. Now, before I move ahead, I would like to tell you something, kids. Okay, just see what I want to say. In this, one question will come. Which D block element, which transition element shows only one valency? So remember that it's not, that's very soft. Zinc, cadmium and mercury are being very soft. So not considered as transition metals. So answer will be which will show only one valency. scandium will show only one valency. One thing is clear. Now I would like to tell you something. Just see, kids. The preparation of potassium dichromate and cheminophore, some basic terms, some very basic terms. And keep it in your hippocampus. Keep it in your hippocampus. That generally the bond of equality is good. What do you mean by this? Generally the bond of equality is good. What is the meaning of this? Sorry. Meaning of this is smaller cation will form a happy bond with the smaller anion. Stable. Large cation larger anion stable. Now how to find out in case of anion who is larger, who is smaller? Remember that smaller anions fluoride, hydroxyl, oxide. Now larger anion, I am going to tell you larger anion, all multi-atomic, like carbonate, phosphate, oxalate, chromate, dichromate, etc. All they are, along with bromide and iodide, they are larger anion. And cation you know very well, right? This thing is very important. Second point which is very important. Second point, CrO4 2 negative is stable in basic medium. CrO4 2 negative on adding acid will convert into dichromate Cr2O4 2 negative. If you remember these 2 points, then you are winner. And before this point, let me tell you, see, if I say that I am having Na2 Cr2O7 and one we are having K2 Cr2O7, who is more stable? Just see, if I talk about dichromate is same, larger anion. Now sodium, potassium, hydrogen, lithium, sodium, potassium, rubidium, cesium, francium. So who is larger? Sodium and potassium. And going down, size increases. So this is a smaller cation, larger anion. This is a large cation, large anion. So this is stable. It is more stable. And whenever it is more stable, lattice energy will be more than hydration energy. And whenever lattice energy is more than hydration energy, less soluble in water. And there, smaller cation, larger anion, hydration energy is more than lattice energy, that means more soluble in water. If you are able to understand this much, then only I can move ahead. If you got it this much, just to let me know in the chat section. If you are able to understand this much, then I'm going to give you the best. Do let me know in the chat section, kids. Everyone, just do let me know. Yeah, I will tell you preparation of KMnO4 after dichromate. First I will tell you potassium dichromate, and after dichromate I will tell you KMnO4, right? Show me fire in the chat section if you're ready. If you're ready, everyone, just show me fire in the chat section now. Preparation of potassium dichromate. So I'm going to start with Fe1Cr2O4. This is known as iron chromate ore. What? Iron chromate ore. Everyone say iron chromate. 1, 2, 4. 1, 2, 2. 2, 2, 4. 1, 2, 2. 2, 2, 4. Iron chromate ore. 1, 2, 2. 2, 2, 4. Iron chromate ore. Now, iron chromate ore was treated with excess of air in presence of sodium carbonate Na2 or potassium carbonate K2 CO3 or sodium carbonate, whatever you want to add, you can add Na2 CO3, basic medium. So excess of oxygen, and this no need to cram, you can decode it, this reaction. First let me write down what you will get. Just see, you can write it like this: iron chromate ore, like FeO and Cr2O3. Now its oxidation, ferrous oxidation, ferrous plus 2 will get converted into Fe2O3, ferric Fe3 plus, and chromium here 3 oxidation state on oxidation should get converted into chromium plus 6. But remember that chromium plus 6 in both of these, it is plus 6. Whether I write down Na2 CrO4, it is plus 6, or I write down Na2 Cr2O7 also, then it is also plus 6. Then which one we have to suggest? Basic medium. Who is stable in basic medium? As I have told you, in basic medium, who is stable? Chromate is stable in basic medium, so chromate will get formed. Am I right? Just to let me know. This will not get formed because it is not stable. This will get formed in basic medium. This is stable. So what I will get? I will get NLO, Na2 CrO4 plus Fe2O3 plus water. Now sodium chromate I have got first step. In first step I have got sodium chromate. Let me move to second page. Sodium chromate Na2CrO4 is a yellow solution. Why yellow solution? Because all salts of sodium are soluble in water. All salts of sodium are soluble in water. Now this is a smaller cation and this is whatever, leave it. I will add acidic medium. If I add H2SO4 in acidic medium, who is stable? Dichromate, orange color, Na2 Cr2O7, orange colored. Dichromate. Now smaller cation, larger anion, if they get chance to react with KCl. Now what's the problem in KCl? KCl, large anion, large anion, smaller cation, the exchange offers, so it will form K2Cr2O7. Now, this way you have prepared. Now see, that was Na2Cr27. Hydration energy here is more than lattice energy, so more soluble in water. It's being more soluble in water, and that's why it is not used in primary standard titration, not as primary standard during titration, because it will absorb moisture from the atmosphere and more water will come and its concentration will get changed. So it is deliquescent in nature. Deliquescent, if you understand, will absorb moisture from the atmosphere. Deliquescent. And this is less soluble in water, and that's why used as primary standard during titration. Second thing, let me tell you, it's +6 oxidation state. So the number of unpaired electrons are 0. Number of unpaired electrons are 0. There are no unpaired electron here also. Number of unpaired electrons 0. So its color is not due to DD transition. Remember that. Color is not due to DD transition. Color is not due to DD transition. What I am saying, are you getting my point? Color is not due to DD transition. Then who is responsible for color? Examiner will ask. So remember that, who is responsible for the color? Color is due to charge transfer spectra. Charge transfer spectra. Charge transfer spectra. Now kids, I will come to KMNO4, but before that, some people's battery got discharged, and let's meet at 12:15. It's the time for break. Let's meet at 12:15. Okay, next day. Will you come with full on energy? If I give you one break, will you come with full on energy? Kids, do let me know. Make a promise. Yeah, Mina knows Rubis is always soluble. Very good. Make a promise that you will come with full on energy, then only I will give break, otherwise not. Very good, very good. So let's meet at 12:15 AM. everyone. How's the Josh? Let me check it out. You are still wake up. Wake up, wake up, wake up, everyone. Do let me know in the chat section what's going on. Where are you and how is the Josh? How is the energy? Sahana, really awesome. I'm before time. I'm before time. You see, I'm in time, not on time. Baba is in time, and you kids are also in time. 1 minute is still left. 1 minute is still left. Wow, that's really awesome. That's really awesome. So I will give you the feel of each and everything so that you can understand what actually the teaching means. Really, everyone? I want to see green hearts. I'm in time. Sahana and Rolex. Good morning, Lakshmi. Kya baat hai, Rolex? Rajul ready, that view and song. Ha ha ha, yay, Mindtree Gaming. And really, kya baat hai? Then this baat hai. Oh, great. Really awesome. It's good going. The fire is on. Oh my God, everyone. Assalamu alaikum, salam. So, let me tell you about K104. Let's set go with K104. D block is going on. Those who are new, let me tell you what is going on. Let me tell you, kids, D block is going on. If anyone is asking what's going on, then remember that D block is going on right now. And in D block, potassium dichromate is completed. Right now, we are going to move with K104. It's the time for K104. Now, let me tell you what's K104 is the meaning of K104. Let's see if I write down K104. What do you call it? What's the color of K104? K104's color. Everyone just to let me know PPR. What do you mean by PPR? Pinka, purple, red, any of these colors of K104. And if I talk about kids, what's the oxidation state? So 1 plus x minus 8 plus 7. This is maximum oxidation state, or you can say HOS, highest oxidation state. Now, my dear students, if K104 is added in acidic medium, what will you see, kids? In acidic medium, remember that first of all, whatever you want to say, 2 1 ja 2, say 2 1 ja 2, 2 2 ja 4, 2 3 ja 6, 2 1 ja 2, 2 2 ja 4, 2 3 is 6. In acidic medium. In neutral, remember that, or faintly alkaline. Faintly means what? Faintly means slightly alkaline. Remember that. Slightly alkaline or basic. Now, strongly basic medium, what you will get? Strongly basic medium, you will get this one. Now, my dear students, let me complete this. This is the oxidation state. Now, if we talk about N factor in this, the N factor is final minus initial. N factor is 5. Here N factor is 4, 7, 2, 4, and here N factor is 1. And here you will get K104, that is being green color. And what's the name? No, K2MnO4. Now its name is potassium permanganate. Remember that? Potassium permanganate. What is the name? Potassium permanganate. And here it is green color, potassium manganate. Now kids, if this much is clear, once I will ask the same thing on the next page. I want to have your help. I would like to take your help and you have to help me. KMnO4, one arrow, second arrow, third arrow, Mn plus 2, MnO2, M, K2MnO4. If I want to ask what's the equivalent weight, molecular mass, it's 158 divided by n factor, 31.6. Equivalent weight 158 divided by 3, 52.67. What's the equivalent weight? 158 divided by 158. Now, my dear students, remember that this K2MnO4, if you add acidic or neutral medium, it will change into two compounds. This is known as disproportionation in acidic or neutral medium. Disproportionation. Disproportionation will take place. It will give it two type of things. Everyone got it? This is really awesome. If you remember this much, then I can tell you the preparation of KMnO4. Everyone, just to let me know, are you able to understand? Is everyone able to understand? Just to let me know. Just to let me know everyone is able to understand this much. Now, let me tell you the preparation of KMnO4. Preparation of KMnO4. Pyrolusite MnO2, if you add excess of oxygen and KOH. Now remember that oxygen is electron snatcher. It's being electron snatcher. Now plus 4, it should convert into plus 7 maximum oxidation state, but the medium is basic. And in basic medium, you know that who is stable is strongly basic, strong base, it is strong base. So in strongly basic medium, we know that green colored compound K2MnO4 will get formed, K2MnO4. Now K2MnO4, if you add acidic medium, if you add acidic or neutral medium, will undergo disproportionation. So it will give you KMnO4. It will give you KMnO4, and once again your MnO2 black colored powder MnO2 is back, so it is recycled back to this. It's being recycled. Are you getting my point? Now from this KMnO4, we got KMnO4. This is the way. So KMnO4 and potassium dichromate both are being oxidizing agent. Remember that what they will do. Effect of KMnO4. If you say there is H2S, sulfur is in -2 oxidation state, whether I add KMnO4 or I add potassium dichromate, so I add KMnO4 or I add potassium dichromate K2Cr2O7 in acidic medium concentrated H2SO4, both they will do the oxidation. This will convert into sulfur, and if I am using manganese KMnO4, then that will convert into Mn+2, or if I am using chromium, that will convert into +3. That their oxidation states positive, and chromium is green colored. It is green colored, and that is being colorless. Remember that, colorless. Okay, this is being colorless. Color is very, very important. Colorless, and this is being green colored. Now if you use Ki, that Ki will convert into I2 by them. If you add ferrous, ferrous will convert into ferric, undergo oxidation by them. If you use what to say, stannous, stannous will convert into stannic by them. Are you getting? I hope that everything is clear to each and everything. But remember that one thing, one point to be noted, my lord. If I add Ki and I add KMnO4 faintly alkaline, KMnO4 faintly, this is asked number of times, faintly alkaline, then you will get IO3 negative. Point to be noted, my lord. You will get IO3, iodate. Is this clear? Now I will tell you something else, but before I move ahead, do let me know this much is clear to each and every one of you kids. Do let me know if this much is clear to each and every one of you. Then we can deal with questions also if this is clear. This much is clear or not, kids? Do let me know. Everyone. Very good, very good. That's really awesome, really fantastic. Now it's clear. Now let's it go. Hey, can you see any sleepiness in my eyes? This I got as a reward at my offline coaching at Jaipur. You know, I'm taking JEE Advanced over here. So, best performance, the result. So, I got as a reward. Now, this is really awesome. And these are the colors. If you can remember, that is the cramming part. If you want to do that, now let me tell you what is important over here. This is unpaired electron is 0, that's why it is colored. If unpaired electron is 0, so some are important. This manganese 2 plus is important and cocoa is important. These two are important. This is having unpaired electron 0, so colorless. Whenever there is colorless, that means the value of N is 0, unpaired electron 0, right? Now this is really awesome, very, very important. So should I give you the trick? Should I give you trick for it? How many of you want to have trick for this? Baba HSP's trick. How many of you want? Now, how to find out unpaired electron? Just let me know. Do you want or you don't want? If you don't want, then why should I give? Why should I give if you don't need? Without any need, nothing to give. If you really need it, then do let me know in the chat section. Then only I will give you. Show me green hearts along with some fire. Hey everyone. Everyone, I want to see some fire in the chat section. Then only I am going to give you. Yeah, very good Vishal, very good Sahana. Wow, fast. Now this is the way chat is running. That's really awesome. Now see kids. This is really awesome, really awesome. Now see. Remember that if unpaired electrons are 1, then 1 point something will come the value. Whatever the number of unpaired electron, add something after point. Say 2, 2 point something, 3, 3 point something, 4, 4.9, 5, 5.92, 5, then 5.92. Now if somebody is saying that we are having Bohr magneton is equal to 5.92, then others, what others will do? Other students will do like this. (5.92) under root n into n plus 2 Bohr magneton. Then they will solve it. It's very lengthy method. Can you see? Very, very lengthy method. Very, very time taking lengthy method. What you kids HSPN will do, if they have given Bohr magneton 5.92, just take this digit. That means unpaired electrons are 5. 4.90, unpaired electrons are 4. 3 point something, unpaired electrons 3. Just before the point is the number of unpaired electrons. Just before point, the value indicates number of unpaired electrons. Got it? Everyone got it? If yes, this trick you are liking, show me green hearts. If you like the trick, whatever the value is given, that is the number of unpaired electrons. Let me see that you are able to understand or not. You got it or not? Just to let me know. Everyone got it or not? Fast. Very good. Now, first series, this though you know very well, not required. This also. Here one thing is important in this chart. What I want to say, standard electrode potential M2 to M, all they have got negative value except this copper. Just see copper, except copper. See, this is really important, holds a hell lot of weightage. Only see this copper has got positive value. So remember that. And this you can see from here. You know that hydrogen, like Baba sir. Copper lies below hydrogen in the electrochemical series. Can you see copper? They are reactive elements and their power to undergo oxidation. Their SOP is positive. If you have studied electrochemistry, you know very well. Their SOP value is positive. They are good reducing agent. But here copper will gain electron and will try to undergo reduction. SRP is positive. Everyone got it? Is it clear? Is it clear? I hope this is clear. Now, enthalpy of atomization. These elements are having more standard enthalpy of atomization, just like near about chromium, molybdenum, tungsten, right? Now, this is really important, very important. Why this is very important? The size of, see, this is of 3D. 4D, 5D size is almost equal. Let me write down what's this. If I write down science teacher, very crazy man, felt cold in night with cousin. Then if I write down like this, scandium, ytterbium, lanthanum, actinium, titanium, zirconium. Let me use another color. Why? I will let you know. Titanium, zirconium, hafnium, rutherfordium, vanadium, niobium, tantalum, dubanium, chromium, molybdenum, tungsten. Now what should be over here? What should be over here? Sg, siaborgium, manganese, titanium, rhenium, Bh, bahurium, hasmium, Mt. Now see, From where? Lanthanum is starting from here. If I say the size is increasing, its size up to here increasing, this is the size, remember that. But means this size is better than that, and this, it's increasing. But if I talk about these elements, then here to here size is increasing, here to here size is increasing, but their size is approximately same. And who is responsible for same size, same radii? Who is responsible? Just before this element there is lanthanum. So in between this there are how many elements? 14 elements. And in between this there are 14 elements, and they are putting lanthanoid contraction, lanthanoid and actinoid contraction, lanthanoid and actinoid contraction. And due to this, the size is like this. This size is almost same. Who is responsible? Due to lanthanoid and actinoid variation in atomic size. Now, kids, how many of you got it? If you haven't got it, do let me know in the chat section. And if it is clear, then do let me know with the green hearts that yes, you got it. Who is responsible for this? Responsible is responsible. Who is responsible? Lanthanoid and actinoid contraction. Got it, kids? Just to let me know. Fast, kids. Very good. Sahiti, Sahana. Very good. Sahiti 40, Avilasha Datta, that's really awesome. Fantastic, kids. Now, ionization enthalpy, you know very well. It's standard electrode potential. Already I have explained, and this though not required. Already I have explained. Now, oxides of 3D. You can see I have told you these are having number of oxidation states, because manganese exists in +7. It shows number of oxidation states. Now F block elements, remember these. And what type of question will be asked from F block? Remember that good cellulose, GD CULU, GD cellulase. Now, which one is most important in this? Let me tell you which one is most important. Remember that God is number one. God is one. Remember that God is one. That means D1. In gadolinium, the configuration is D1, and they will ask you the configuration. See, where is gadolinium? Here is gadolinium. And if D is 1, so they will ask how to write down the electronic configuration of gadolinium. Its atomic number is 6 and 4. Now see, let me tell you, 64. And if you don't remember the electronic configuration, then remember that see, Prime Minister and PM take out this. See, Prime Minister and PM are same. The trick for it, see, Prime Minister and PM are same. See, Prime Minister and PM are same. You God, you has become God, but we need God. God's atomic number is 64. Now they will ask how to write down the electronic configuration, right? Now remember that we know that helium, neon, argon, krypton, ira, cara, xenon, helium, neon, krypton, xenon, radon, and augi. Now see 2, 10, 18, 36, 54, 86, 118. Now see kids, 64 is lying after, 64 is lying after 54. 54 and 64, how much is the difference? 10. It is the difference of 10. So can I write xenon? I have written xenon. Xenon stands for how much? It stands for 54. Now I know that which lanthanoid is there. Lanthanoid is in 6th period. How to find out that lanthanoid is in 6th period? Let me show you. Lanthanoid is in 6th period. How to find out? Just see. Hydrogen, lithium, sodium, potassium, rubidium, cesium, francium. 1, 2, 3, 4, 5, 6, and 7. This is, see, 6th period. 6th period, we know that side, how much was the atomic number? We know very well that 54, 55, 56, 57, now 58 to 71. 58 to 71, these are 14 elements. So we know that it is 6th period. And whenever S, if I talk about S, 6S, then what D will be there and what F will be there? F will be N minus 2F, always N minus 2F, and always N minus 1D. If you know this, then 6F, 6S, 4F, and which D? D will be 5D. So if I say that I want to write down for gadolinium, let me go back. Gadolinium was over here. Gadolinium was over here. Now I am supposed to write down 64. Then 54 is this. Then I will write D1 and 6S2. I have to write 6S2 and I have to write D1. D1 means 5D1. So how much I have taken? 2 plus 1, 3. I have to make 10. So 3 already I have taken. So 4F, how much should I write? 7, 8 to 10 and 54. So 54 plus 2 plus 1 plus 7 is becoming 64. So this should be the correct electronic coefficient and half-filled configuration. Just if you want to see, it should be given like this only. You can write by yourself. Gadolinium 4S7, just see kids what I said, 4S7, 5D1, 6S2. Same configuration I have told you or not? If you really liked it, appreciate with green hearts. If you're really liking it, do let me know kids in the chat section that yeah, really I'm telling you each and everything up to the mark. The clear-cut explanation Baba HSP is giving you for each and everything, and without seeing the notes, I'm writing the whole electronic configuration and all the elements. Kids, Vishal MH, very good. Vishal MH, that's really fantastic, Vishal MH. Now this is lanthanide contraction, already I have explained. Oxidation state, already I have told you. Now how to see the reactions, the formula of lanthanum. Treat lanthanum like aluminium. Treat your lanthanum like what I'm saying, like aluminium, So aluminium, the oxidation state is +3, so here also +3. Now you can write down any formula. What I'm saying, once again let me tell you, aluminium is always having +3, so like this lanthanum is also having +3. So by remembering it, you can see like Al2O3. If I say Al2O3, it is forming Ln2O3. If I say AlCl3, if I say AlCl3, it is forming LnX3 halogen with water. AlOH whole thrice, like AlOH whole thrice, it is forming like same thing. So I can say that yes, like aluminum nitride, it is forming lanthanum nitride. It's easy. If I say Al2S3, Al2S3, it is forming like same like aluminum. Everything is like aluminum. So it's really easy or not? This analogy is making it really easy or not? It's true, let me know. It is really making it easy or not? Just to let me know. Like aluminum, treat lanthanum. Now let's see the questions. Actinoids also. See, in actinoids, let me tell you one thing. Remember very clearly. I'm telling you, kids, that thorium, in thorium, remember this thorium, there is D2, exceptional configuration. Now D1, protactium is having D1, uranium is also having D1, neptunium is also having D1, and curium is also having D1, and yeah, right, and actinium already will have D1. So protactinium, uranium, neptunium, curium, 1 2 3 4, Thors Pa, and are same on similar path, Thors Pa on similar path. Okay, so remember this. Have you got it, kids? Have you got it what I'm saying? They all are having this one is having D2, rest they are having D1 configuration, D1, but never the examiner has asked. Examiner has just asked once or twice about gadolinium, but these things examiner never asked. So least important, but it is there. D1 configuration. Rest all are having, see, D0. All are having D0. Only these are having D1. So this is the oxidation state. +3 is common oxidation state. In lanthanoid and actinoid, all they are having +3 as common oxidation state. Can you see the common oxidation state? Now here is the question. Just to let me know in the chat section. Yes, kids. What should be the correct answer? Which one of the following ions exit DD transition and paramagnetic as well? So you know the answer very well. For DD transition, yeah, very good, Janvi. Your answer is absolutely correct, because if I talk about chromium, +6, the value of N is 0, +6 value of N is 0, +7 value of N 0. So all these three, the N value is 0, no unpaired electron. Manganese is having +6 and it is having 1 unpaired electron. So it will show this is the correct answer. This is the correct answer. Well done, well done. Now, yeah, very good question, and that's why I taught you this thing. Very, very good question. I want to see the answer, correct answer, kids. Do let me know. Fast, kids, fast. Now only I will take not more than 30 to 40 minutes. I will tell you that first, after completing D block, I will go to P block and tell you what is important from the P block. I will let you know. B, everyone is going for B. Let me see what they have written. They have written 2.84 Bohr magneton. That means 2.84. What I have told you just before this, this is giving number of unpaired electrons. So the value of n is equal to 2. How to find out? Titanium, the value of n is 0. Here the value of n is 0. Chromium, cobalt, how to find out? So see, science teacher, very crazy man, felt cold in night with cousin, right? So let's see chromium. Chromium is 24. So it is 3d5, 4s1. So they have written chromium 2 plus. So 2 electrons gone. So 3d4. This can't be the answer. So cobalt is 21, 22, 23, 24, 25, 26, 27. So just write down reverse of it, 3d7, 4s2, and cobalt 2 plus 2 electrons gone, 3d7. 3d7 means 1, 2, 3, 4, 1, 2, 3, 4, 5, 6 and 7, 3 unpaired electrons. So which answer you have given? Which, according to you, which is the correct answer? D. Let me check it out. Nickel 28. So 1 will be filled. Yes, this is correct answer. Very good kids. I hope everyone is able to understand. Wow. Now, reason of Lanthanoid contraction: negligible screening effect of f orbital, increasing nuclear charge, decreasing nuclear charge, negligible screening effect. So A should be the correct answer, negligible screening effect. Wow. Now, which of the following Lanthanoid ion is dimagnetic? So unpaired electron. If unpaired electron is 0, that means it should be dimagnetic. This is clear cut. So you can see the answer. Need 2000 ytterbium, right? Now, tell me the answer. Scandium is a transition element, but zinc is not, because I want to see the answer in the chat section. Okay, fast. C. Harni Reddy is going for C, and let me see the answer as C. Wow, Harni Reddy, congratulations. Now let me come back. Those who are unable to understand, let me explain. In case of scandium, 3d orbitals are partially filled, right? But in zinc, these are completely filled. That's why they are soft. Zinc is having the value of is not having unpaired electrons, and that's why it is soft. That's why no metallic bonding. Right? Let me make it fast so that each and everything get completed. Now, for the successive transition elements, the stability of +2 oxidation. Okay, let me tell you first of all, science teacher, very crazy man. Now, its +2 oxidation state is stable. Before this, +2 is unstable. And they will easily oxidize. +2 is unstable, and they would like to undergo oxidation to keep +3 and whatever the oxidation state. So these are good reducing agents. They would like to undergo oxidation. So good reducing agents. These are very good reducing agents. So for the successful and chromium, manganese, iron core, the stability of +2 oxidation state will be there in which of the following? See, any element like here, scandium is there. So scandium can't be this side. Manganese +2 is stable. Okay, this side no element is there. So it has become tough. So manganese +2 oxidation state is more stable than how? Chromium. Where is chromium? Chromium should lie at the last. So this can't be the answer and this can't be the answer. Answer should be over here. And iron, cobalt, manganese should be on this side. Out of cobalt and iron will undergo oxidation. So what answer you are going to give? Just I have eliminated out 2 options. Do let me know. C. Yeah, C should be the correct answer. And let's see. Oh, cobalt plus 2. C will be the correct answer. C is more expected. Chromium plus 2. Okay, let's see this question. I think a little bit confusion is there, right? So this should be, what should be the answer? In which of the following pairs are both the ions colored? So scandium plus 3 unpaired electron 0, unpaired electron 0, they can't be the answer. Now what should be the correct answer out of these two? Just to let me know what should be the correct answer out of these two. C. Sahana is going for C. Let me check it out whether C is the correct answer. Oh, this is the correct answer. Why not this? Titanium. See, scandium, titanium. In which of the following are both the ions colored? See, this titanium is having one unpaired electron, but copper, it's gone. Copper, if you see copper is 29 and it is 3d10 4s1, and if you remove one electron, copper plus 1, so it will become 3d10. The value of n is equal to 0. So that is the correct answer. Got it, Sahana? Is it clear? Is it clear, Sahana? Now, maximum oxidation state is executed by. It's very simple questions, no need to ask. So copper, you know that answer is very clear, very simple, very simple. Now coordination chemistry, already I have told you P block. Now it's a time to go with P block. Show me some fire in the chat section if you are ready for the P block. Let's see how well managed, with well direction HSP is moving on. See, KMNO4 and potassium dichromate already I have explained. See, potassium dichromate explanation I have told you or not. This equation, these three equations already I have explained, and this already I have explained. Potassium permanganate, each and everything I have told you. This preparation I have told you, each and everything. Secrets, each and everything. The reactions I have told you. And see, in faintly alkaline, I will show you faintly alkaline. Where is faintly alkaline? See, faintly alkaline sulfur. In neutral or faintly alkaline, just see, I have told you iodate. Iodate is the answer. I have explained on it number of times. They have asked this question. Very, very important. Number of times I have shown you, right? So let's move with P block. Let's go for the P block kits, and what is important from P block, let me tell you. Ready? Because P block is very, very important. What is the important thing that what the examiner can ask? I will tell you that thing, right? Oxygen family. Say in nitrogen oxyacids, just see this chart, how much hard work we have done for you kids. This is important from P block. Oxyacids. Oxyacids, very, very important kids. Now, kids, smash the like button, make it 500, then I will start teaching you. Make it 500 kids. Hit the like button. Then I am going to tell you about this oxyacids. Everyone smash the like button so that I can start telling you oxyacids. Very, very important. Let me check it out whether you have smashed it or not. Okay, now let me tell you how to write down the oxyacid so that you can clearly write down oxyacid. See kids, this whatever they have given, let me show you oxyacids. How to name it, this is really very important. Phosphorus in +5 oxidation state or +4, whenever it is in higher oxidation state, you have to add ic acid. Ic, word ic acid will be there, right? And if it is in lower oxidation state like +3, +2, +1, lower oxidation state, you have to add us acid. One point is clear, when to use ic, when to use us. This point is clear or not? When to use us and when to use ic, this point is clear now. Remember that for an oxyacid, this much is a necessary condition. This much is the must condition. Remember that this hydrogen should be there, acidic hydrogen, right? This much is necessary. If you are getting this much, then I will give you the mind map so that you can understand it. See, if I write down something like this, H3PO4, you know from the beginning, your childhood, H3PO4, P double bond O for an oxyacid, this much is the necessary condition. Now, what else I will write? OH. Whenever we are having such type of thing, we can directly write ortho word. Ortho, not with benzene, related with benzene. Ortho. Now, phosphorus or phosphoric, it's +5 oxidation state. So, phosphoric acid. Now, if you take two molecules and remove water from it, remember that if you take two molecules, take 2 moles and remove water from it, then you are heating it. Heating is required 100 degrees Celsius. Then the word for heating is pyro. We will use pyro. Now let's see. P double bond O, OH, O, P double bond O, OH. Now pyro word will be used, but us or ic, for that, let's see the oxidation state. +5, higher oxidation state. So pyro, phosphoric acid. Now if you remove one oxygen from that, P double bond O, OH, P double bond O, OH. This is having less oxygen, so the word hypo. Now ic or us, so the oxidation state is +4, once again ic. So hypo phosphoric acid. Now kids, if I directly remove water without taking 2 moles, then at 610 degrees Celsius, water will get removed. There you have used ortho here, pyro, only one thing is left, meta. So water H2O will go. So P double bond O, OH, coordinate bond O, +5 oxidation state. So this is metaphosphoric acid. Now it is not stable, so it will either trimerize or polymerize. They will ask the question, this will trimerize or polymerize. Remember that, polymerize. So it will form HPO3 whole thrice or HPO3 whole n. Now, if I write down like this, H3PO3, how I will write down? See, OH, P double bond O, OH, H. This H is making it reducing because directly attached. So its n factor is only 2. Remember that n factor is just 2. And now the oxidation state -2. So +2, -1. So +1, +1. So -1, -1. So +1, minus pencil, +3. +3 means it is orthophosphorus acid. Orthophosphorus acid. And it is also known as phosphonic acid. Remember that, also known as phosphonic acid. One more is there, last but not the least. And what is that? That is P double bond O, H, OH. Only one replaceable H. So n factor is 1. And it is known as phosphenic acid. Phosphenic acid. I hope kids, everyone got it. How is the mind map? You can say Oxyacids mind map Baba has given. Kids, do let me know. How is it? Really, you must have got it for the first time. You must have got it for the first time, kids. Do let me know. Baba is multi-talented or not. Inorganic chemistry, Baba is teaching without any slides. How to calculate oxidation? Anyone, please? I will tell you. Akash, don't worry. See, Akash, don't worry. Let me tell you oxidation state, how to calculate. See, directly. There are two ways. Just see. Once I can write H3PO4 this way, or once I can write down P double bond O, OH, OH. Just see. Here, hydrogen is having 1. So 3 into 1 plus X plus 4 and minus 2 is equal to 0. So X is equal to 3 plus X minus 8 is equal to 0. So X is equal to plus 5. This from the molecular formula. And here 2 minus 2. So plus 2. Minus 1 from this side. So plus 1. Minus 1. So plus 1. Minus 1. So plus 1. You can see here also it is coming out plus 5. Can you see? Who has asked this question? I think it is clear. I have told you in both the two ways. I hope you got it. Somebody asked how to calculate oxidation state. Baba has seen the doubt and explained. Kids, really liking. Just to let me know. Clear? Okay. This is clear. Which is having strongest reducing property. See, the question has come. NEET 201. The one in which phosphorus is directly attached to more number of hydrogens directly. Yes, which one? So answer this question, kids. See, when it has been asked, you can see and you can answer it. Do let me know, kids, the correct answer in the chats. Fast, kids, fast. C. Yeah, C is the correct answer. C is the correct answer because in this, direct hydrogens are directly attached. This is OH and two hydrogens are directly attached. This is making it to be. Now there is one more method. You see the oxidation state and H3PO2 is 3 plus x minus 4 is equal to 0. So x is coming out plus 1. So it is having plus 1 to plus 5 maximum power to undergo oxidation, maximum electrons to donate. That's why this is answer. Number of ways you can see. So they have given, see, the strong reducing behavior of, once again, NEET 2015. My God, so many times they have asked this question. Just see, that's why I have explained. So many times they have asked this question. Can see A. Let me see whether A is the correct answer or not. Wow, kids, you are really liking the way Baba is teaching you inorganic chemistry. Just to let me know, have you ever seen anyone teaching inorganic chemistry like this? Once again, leave it, you can do it. Too much time is getting. Now see oxygen family. But before this, let me come to the nitrogen family. I want to tell you one thing. They will ask questions from this table. This table is very, very important. Just see which table. Nitrogen, phosphorus, arsenic, antimony, bismuth. This is okay. Where kids? Now nitrogen, atomic number, electronegativity is okay. Ionization, it's okay. What is important? Let me tell you. Which slide is very, very important? Let me show you that slide. This to everyone knows that -3 to +5, because nitrogen is having 7, so 2, 5. It can lose 5 electron or can gain 3 electrons. So its scale is -3 to +5. Right, -3 to +5. Now oxidation state, already I have told you, -3 to +5. No, the inert electron pair effect, we know that, kids. If I talk about 1, 2, 3, 4, 5, 6, 7, and this is nitrogen, phosphorus, arsenic, antimony, bismuth. Now see, their electronic configuration is like 2s2 2p3, 3s2 3p3, 4s2 4p3, 5s2 5p3, 6s2 6p3. But in this way you won't be able to give the answer. So let me tell you one trick. Sunday morning, everyone says Sunday morning, sip SDP, simple DP, then safe DP. You can answer any question with this. Sunday morning, 2 times sip, simple DP, safe DP. Say everyone, then only you can answer any question. Follow me. Sunday morning, sip, simple DP, safe DP. If you say this much, now see, kids. 1s, 2s, 2p, 3s, 3p, 4s, and D is always n minus 1D, and F is always n minus 2F. This you have to remember. So 4S, 3D, 4P, 5S, 4D, 5P, 6F, 4F, 5D, 6P. Now 6 in the 6, you have to go like this. So let me go back. 6 safe DP. So safe DP, safe DP. F and D will come in between this. F and D, which F? Which F? 4F and 5D will come, then 5P will come. So they will put scandite contraction and lanthanoid contraction. Scandite and length. Scandite means scandium. Scandite means scandium, and lanthanoid contraction due to scandite and lanthanoid contraction. This will become inert. The effective nuclear charge of nucleus will be more. This nucleus proton will apply more force of attraction, and these electrons will not be able to participate in the reaction. So here plus 5 oxidation, here minus 3. See the minus 3, because the metallic character is decreasing. So the electron donation power is, metallic character is increasing or decreasing? Increasing. Metallic character is increasing. Metallic character is increasing. So donation power is increasing and acceptance power is decreasing. So its minus 3 oxidation state is more stable, and moving down the group plus 5 should increase, but due to inert electron effect, these will show just plus 3 electrons to be donated, and they are metals, can't take electrons, so can't show minus 3. So see, stability of plus 5 oxidation state decreases. Why? Because metallic character increases on moving down. Metallic character increases on moving down, right? And plus 3 state increases due to inert electron pair effect, because on going down these will not participate. Are you getting my point? Just to let me know in the chat section. Are you getting my point, kids? Do let me know in the chat section. Are you getting it? Just to let me know, kids. Very good. Harsh Raj Yadav, thank you for appreciating. That's really awesome, kids. Wow, kids, you're liking my inorganic chemistry, that great knowledge, each and everything like butter I'm explaining. Now HNO3 in the case of nitrogen. Oh, this is very important. In case of nitrogen, all oxidation state from plus 1 to plus 4 tend to disproportionate in acidic solution. Which solution? Acidic solution. This is very important slide. Very important slide, because in case of nitrogen, all oxidation state from 1 to 4 disproportionate only in acidic solution, but in case of phosphorus, nearly all intermediate oxidation state in between plus 5 and plus 3 in acidic as well as alkaline solution. Why? What they want to say? Just see, if I say that it's moving like this and it's moving like this, now nitrogen can show minimum oxidation state of minus 3 and maximum oxidation state of plus 5. So if I take phosphorus from here to here, any oxidation state, from here to here, any oxidation state, from here to here in between, that in acidic as well as alkaline solution it will undergo disproportionation, right kids? Will show disproportionation, I hope you got it. And that only, it's nitrogen's nitrogen's, that if I draw this from here to here, so its minimum oxidation state is minus 3 and maximum oxidation state is plus 5. but I will not draw like this -2 -1 0. So it will show disproportionation only from this oxidation state to this oxidation state. This is disproportionation area, but its disproportionation area is bigger because nitrogen is more electronegative, so it is having more affinity for electron, but that is in acidic medium only, but here it is in acidic as well as alkaline. Got it? Very, very important slide. If you got it, I hope you got it. Now, yeah, this is very, very important for this page. Let me tell you very, very basic so that you can understand it. Okay, then I will come to this one. See, very, very basics, very, very basic so that you can understand each and everything. Bond of equality is good. Bond of what is good? Bond of equality is good. What is equality? If I say that I am having H is a small atom. So if I say nitrogen, phosphorus, arsenic, antimony, bismuth, their size is getting increased, right? Size is increasing or not? Now, hydrogen will be more stable with whom? Ammonia in this case, phosphine in this case, arsenic in this case, the cation size is increasing. This is a smaller and smaller, they are more sukhi, smaller and smaller, they are more happier, so stable, right? This is least stable. One point is clear or not? Least stable. Now least stable, most stable, right? So whose lattice energy on going down, lattice energy is decreasing and it is better hydride donor. Least lattice energy, so better hydride donor. And better hydride donor means what? That it is going to lose hydride. Hydride will go in this form by taking electron. So if BiH3 is losing hydride means losing electron, so it is acting as a reducing agent. So can I say that reducing agent power increases on moving down the group? Reducing power increases now it is losing hydride. This is more acidic, so acidic character also increases on going down the group. Acidic character also increases. Am I right, kids? Acidic character also increases. So these are acidic, that is basic. These many things we have got from this. Now see, bond angle, Drago's rule, this is having okay, but no hybridization due to Drago's rule. No hybridization. It's no hybridization due to Drago's rule. You must have studied in chemical bonding. Now BiH3 is a strongest reducing agent. Got it? Reducing character of hydride increases on going down the group. The stability of hydride decreases from ammonia to bismuth. Each and everything, you got it or not? As I have told you, see kids, each and everything is clear. See the slide and do let me know in the chat section. Really you got it? Everyone do let me know. It's a really fantastic thing what I am telling you kids. Each and everything I have explained. Really just 15 to 20 minutes more, not more than that, not more than that. Drago's rule says, okay, let me explain Drago's rules. One student is asking for Drago's rule, let me tell you. Otherwise, it is not required, but if you are asking, let me tell you. Drago's rule. This is from chemical bonding actually. For nitrogen it is not there, oxygen it is not there. It will start from phosphorus, arsenic, antimony, bismuth, oxygen, sulfur, selenium, tellurium. For these elements it is valid. Means for which element it is valid? It is valid for period, which period? Third period, fourth period, fifth period and sixth period. And which group? These are of fifth group and sixth group. Okay. When electronegativity of surrounding atom is 2.2 or lesser, then there is no hybridization. That means bonding takes place without hybridization. In Drago's rule, bonding without hybridization. That's why you must have seen in ammonia the bond angle is how much? 107. But then after that they all have bond angle, that PH3, ASH3, SPH3. Their bond angle is equal to 90 degree or approximately equal to 90 degree. Like it's 94, 93, 92 like this. Now there also if I say H2O, oxygen, sulfur. So I have written here, that's wrong. Here it should be sulfur. Oxygen, sulfur, selenium, tellurium, and polonium is radioactive, so leave it. In water H2O, the bond angle is 104.5, but in rest of others like H2S, H2Se, H2Ta, the bond angle is how much? Near about 90 degree only, 90. That's why Drago's rule. I hope you got it. Let me see in the chat. Drago's rule is clear to you? Somebody asked about Drago's rule. Is it clear? Is it clear or not, Drago's rule? Do let me know. Drago's rule is clear to you or not? These are some special lanthanoid and actinoid contraction. That's why, yes, this is found experimentally. That's why there is long story, long rules are there, but you know, it's not required, not in syllabus, out of syllabus. So only this much from here. Now let's move here. Now here also the boiling point of hydride. Same story is over here. Same story. See, I have taught you. Boiling point. There is abnormality, so it's very, very important. Boiling point. Just remember, it's some exceptional cases there. So it's clear to all of you, right? Now see, if I show you in oxygen family also, I will take 15 minutes more, not more than 15 minutes. Okay kids, 15 minutes more, and that's it. Tasmi, remember troposphere, stratosphere, mesosphere, thermosphere. So this is, you see how good notes I have given, that you can go through it. From sun it's coming, and where the ozone layer gets formed, and ozone 2O2, and this is exothermic reaction, but not that much important. Whatever is important, let me tell you, let me show you that slide, the important slide. This is important slide. Sulfur, remember that this sulfur is rhombic and monoclinic. How many sulfur atoms? 1 2 3 4 5 6 7 8. S8, remember that. How much? S8. Allotropes of sulfur. Now see, sulfur looks like this, gandhak, and whatever the thing, very good sulfur. See, it's really awesome. And this sulfur, see, puckered structure, chair structure. So it's not planar. Remember that it's non-planar. It's what? It's being non-planar. Good notes or not? Do let me know. Good notes or not, kids, for you people? Done really hard work or not? First of all, do let me know in the chat section. Really done hard work or not? Then do let me know, really we have done hard work or not? Very, very good notes. This is all for you kids, for you people. Now see, I will tell you which slide is important. This is not important. I will stay back when the slide is important. Not important. Not that important. Galena, PBS is important. You should remember. SO2 plus H2O gives H2SO3. It's okay, okay. The slide is okay, okay. Not that important. Okay, okay. Not that important. Once it is very important, I will tell you this is important. Important. This is important. This is simple. This is simple. Already I have explained. It's being simple. So don't worry about it. It's being simple. It's okay, okay. Yeah, these are oxyacids. As I have explained, oxyacid how to form. Same mechanism is over here. See, questions are there. This, sulfuric acid. This is okay, okay. This we know very well. This not required. This is important. This is important. This reaction is important. We should know. This is also important. Physical chemistry. In physical chemistry, you have already studied, right? You know that. What's that? If you, this is oleum, this is your what? Oleum, you know very well oleum. Having SO3 gas dissolved in it, right? Oleum, H2S2O7, you know very well. Or you can say H2SO4 liquid and SO3 gas dissolved in it, SO3 gas dissolved in it, right? Never oleum from the following. Let me see, the question is from physical chemistry. It's the physical chemistry question, just see to it. Answer it, kids. Let me see who is going to give the correct answer. A. Let me check it out. A is the correct answer. Yeah, this is the correct answer. Absolutely correct. Now, halogen family. Let's move to halogen family. Fluorine, chlorine, bromine derived from C. So, members halogen family, salt producer, known as salt producer. Very good. Out of this, carnallite is important. Sodium chloride is important. Fluoropatite, that is our enamel. Our enamel is made up of the hardest part of the body. So this also important. These three are important. Cryolite, all four are, five are important. All are important. All are really important. Electronic configuration we know very well. Not required. Electron gain enthalpy, very important. This is very important, kids. Electron gain enthalpy, very important. That maximum is of chlorine. Chlorine is maximum, then fluorine, then bromine, iodine, astatine. Maximum. Chlorine is maximum, then fluorine, then bromine, then iodine, right? Electron gain enthalpy, this is very important. Now, reducing bond dissociation enthalpy. Yeah, here also chlorine is having maximum bond dissociation enthalpy. This is also very important. Remember that. Very important. One more thing was there. One was more important, what I was going to tell you. Yeah, after this, see, Cl2, then it is Br2, then F2, then I2. That's why it is very important. If you see the trend of bond dissociation energy, it's like this. After chlorine, it's bromine, then it is fluorine. Can you see, kids? Very important. Not important. See, fluorine, then chlorine. Very important slide. See how much hard work is done, kids. How much hard work has been done. Can you see, kids? At least show some fire that how much hard work has been done, kids. Really too much hard work has been done. And so, kids, I'm telling you each and everything from the what to say, from the starting only, kids. From the scratch only, I'm telling you each and everything. How much hard work even I am doing, kids. Really hard work is done by your Baba. And this is simple. Reducing standard reduction potential. Fluorine is the having maximum SRP. You should know. Fluorine has maximum SRP value. Maximum SRP. Do you know this thing? Maximum SRP. Yeah, this is important. Only fluorine produces oxygen. Only fluorine produces oxygen. Rest of others, they are not oxygen producer in water. will not produce oxygen in water. So this slide is okay, not very much important, but okay, right? Yeah, I've told you what Cl2 is maximum bromine, then it's like this, already explained. See fluorine's reactivity. Oh my god, see kids. Not important. Important. This is important slide. Not important. See pK value, but pK of what? This is wrong. This is wrong. This is pK of HI acid. This is pK of HBr. This is pK of HCl, and this is of HF. So see pK value of this acidic strength. You can see the acidic strength is in this order. Can you see acidic strength? Yes. Now NEET 2016 paper, very tough paper of that time. Let me see the answer kits. Sahana has given the answer kits. Rest of others, do let me know. Everyone, very good. Everyone. Harsh Raj has given the answer kits, and that's chilled bro Florida to India. The trick for this is Baba HSP's trick. Chilled bro Florida to India for BDE, birthday celebration. BDE, buddy celebration. Chilled bro Florida to India. Not important. Not important. Not important. Important. It's important, right? This is important. This is important. This is important. Important slides overall. Important. This is important. This one is important. This already you know, and this already you know. So it has importance. Deacon's process. Very, very important. Very, very important. Remember that. Not important. Not important. Yeah, this is important. Disproportionation. Very, very important. In physical chemistry also you have seen this is important. Very, very important. Right? Disproportionation. Only 5 to 10 minutes I will take. only 5 to 10 minutes it will get completed. This reaction is important. This is important because it's Aqua Regia. Aqua Regia is royal water. No, Aqua Regia is which water? I don't know. HNO3 is Aqua Regia is which water? Aqua Regia is HNO3 is Fortis, and this is royal water. Yes, it's royal water. Very, very important. Unstable at room temperature. So this slide is very, very important. Slide gets, now see why it is important. Unstable at room temperature. At room temperature, unstable. Hypohalous, halous, halic, perhalic. Remember that hypohalous, halous, halic, perhalic. The names you have to remember, and then only you can form the salt. Like if I write down KOCl, if I write down KClO2, if I write down KClO3, if I write down KClO4, then what should be the name? We should know how to write down the names. Just see hypohalous. Now see how to remember even these names, how to remember. See kids, you know this is ferrous from your childhood, you know ferrous, and this is ferric. Us, ic. All right, just like this, if I say HClO2 and HClO3, this is us, that means hypo, and this is hypo, this is us, means hypohalous, and this is hypohalic. From this 2 and 3, 2 and 3, this much is clear. Now if I write down HClO4, so something is added, so I will add perhalic. Now if I write down HClO something less, so what I should write? No, hypo should not be here, only halous, and hypo will be over there, hypohalous. So both of them are being halous and both of them are being halic. Now their salt, let's see how to write down their names of salt. I write down KOCl, KClO2, KClO3, KClO4. Perhalic, H has gone perhalate, so potassium perhalate. Now hypohalic, potassium hypohalate. Halous means potassium halite. Hypohalous, potassium hypohalite. Got it? Each and everything is clear, kids. Just to let me know in the chat section. It's really awesome and it's very, very important. Everyone got it or not? Just to let me know, kids. Really helping a lot. Thank you, Sahana. Everyone, kids, do let me know really you are getting helped by me or not. Only 5 to 7 minutes. Harsh Raj Yadav, thank you. Thank you, Harsh Raj. Thank you, Siru. Dinesh, thank you. Ranarts, hello. Tej Whitey, thank you. Sahana, thank you. Vishal MH, very good. Rana Sat, Mahalakshmi Polymera, thank you. It's once the class is over, will you give me the feedback? Once the class is over, will you write some words? Okay, now let me show you rest of the things. 5 to 7 minutes more. See, hypochlorous, chlorus, chloric, perchloric. Can you see? HOCl, hypohalous, halous, halic, perhalic. Hypochlorous, chlorus, chloric, perchloric. Hypohalous, halous, halic, perhalic. Can you see? Can you see? Hypohalous. Compare with this. Halous. Compare with this. Halic. Perhalic. Good slides. Very good slide. Night slide. So acidic strength. Acidic strength is having this order. Very good. Good question. Good question. Just see to it and tell me the answer. I would like to see the answer in the chats. I would like to see answer in the chat. What's the correct answer, kids? Sahana is saying 3. Let me see other students. Rana Arts 2. Some are going for 3. Let me check it out. What's the correct answer? Chlorine has the highest electron gain enthalpy. What they have asked? False. See, you have not seen this false. And I think that's why you missed it. Those who have not seen this false. Say shit, this shit, that shit. Improper reading, not proper reading. That's why you missed it. Kids, are you getting my point? This is the reason that you missed it or not. Question is wrong. Let me check it out. Which of the following statement about halogen is false? All form monobasic oxyacid except HOF. This is right. All are oxidizing agent. This is all but fluorine shows positive oxidation state. This is also wrong. This is also wrong. This is yeah, question is wrong. You're right, Sana. Question is having misprinting. Now, noble gases. This is the last topic. This is the last topic, right? Okay. Okay. It's okay. Xenon 1. Where is Xenon 1? That is important. Now, what is important in this table? That let me tell you, it's very, very important thing. Let me show you and let me tell you that in this table, if you see, first thing, electron gain enthalpy in kilojoule per mole. Electron gain enthalpy is positive, means they, if you give energy, then only they will take electron. By themselves, they are not having any tendency to take electron. So they take electron forcefully. They have no tendency. See positive value. Positive value shows no tendency of accepting electrons. There is no tendency of accepting electron. One more thing. Yeah, rest is okay. Only one point is important. And they have very high ionization potential. Two things. Now xenon 1, where is xenon 1? Only that reaction is important. Xenon reaction. Let me come to the xenon reaction. This is already I have explained, important. Xenon 1, where is xenon 1, kids? Yeah, this is important. These reactions are very, very important. Nalla iriku romba sulbham. Important reactions. See, xenon by itself will not react. I've told you it's endothermic reaction. It is requiring approximately 700 Kelvin temperature to form XCF2. And if you want to react more fluorine, see, temperature as well as pressure you have to increase. 700, now 900 Kelvin and more pressure. Now if you want to snatch all the electrons, so temperature you have to decrease. 700, 900, now only 600. And pressure you have to increase, then you will get XCF6. High pressure, low temperature. Temperature is more, but less than these two. Approximately these are 700 Kelvin, 900 Kelvin. So lesser than that, it's 600 only, 600, but pressure you have to increase. All the types of fluorides will get formed. So important. Now XCF4 and this hydrolysis is important. This is also important. And this is also important. This is also important. Partial hydrolysis given in NCERT. And these are the from chemical bonding. You must have studied chemical bonding. You know very well. If you don't know, then tell me in the chat. I will let you know how to find out the structure. How to find out the structure, I will tell you. Just to let me know in the chats. If it is clear, then no problem. If it is not clear, then do let me know. I will tell you how to find out the shapes. Do let me know, kids, in the chat if you want it. Okay. You want it? Okay, see. Whenever you want to find out the structure, always do one thing. Always do one thing. First, find out steric number. After steric number, find out hybridization. after hybridization find out electronic geometry. After electron geometry find out shape. After shape find out dipole moment. So for example, if anything you want to find out XCF2, for example, if we are interested in XCF2, so xenon is having 8 electrons in the outermost shell, so 2 fluorine, so steric number is equal to number of sigma bonds plus number of lone pairs which are localized. Sigma bonds are 2 plus 3 lone pair, it is 5, so it is sp3d. sp3d, so remember that is xenon, the lone pairs will occupy equatorial position, and fluorine will come over here. So it is linear in shape. I hope you got it. That's why it is given over here. Clear? Just see. Any other structure you want to know, then I will tell you. Anyone, just let me see. Last 2 to 3 minutes are left. Last 2 to 3 minutes. Just see to it. It is clear or not? Do let me know. Very good, Vishal MH. Now, previous question answer is C. Let me check it out. Which one? Okay, no problem. It's okay. See, questions I have told you now, they are asking from here. Completed kids. It's completed. Each and everything. This already we have completed. Now, how was it? Kids? Do let me know. How was the session? How was the overall session, kids? Do let me know. Just do let me know. Really, I have done the justice, started with coordination chemistry, gone through D block, and then what? The P block also I have completed, D and F block, each and everything done and dusted. Not even a single thing is left, kids. So once the class is over, whenever you get time in the morning, when you wake up in the morning, if you get time, will you write how speedily and how much in detail, with how many efforts, whatever the efforts I have applied? Really good teaching with best examples, visualization I have given. Just to let me know in the chat section. Let me see, kids. Wow, Vishal, Sahana, really awesome. Really thanks to each and everyone. Great. Meenak, wow. Boost Gaming, thank you. So will you write once the class is over in the morning? I would like to see your comments in the morning. Okay, I will give GOATED level teaching. Wow, Sana, I will give written reply also, right? Sanju, wow, Sanju. Oh my God, Vishal MH, wow, great, really awesome. So kids, go through each and everything, whatever I have gone through, whatever I taught you, kids. And I would like to say that once you get time, try it out and share it to maximum people, and share it each and everything, kids. This was the really awesome, kids, isn't it? This was the really awesome or not? And I would like to say, kids, this was also really awesome. This was also really awesome. And whenever you get time, kids, share it to this one also. I would like to say that help others and share it to society, your classmates. What thing I would like to say, that this one, that this thing I would like to say, that share it to everyone and tell them that what thing is available just for rupees 13,499. Whenever you get time, share it to each and everyone, kids. It's iconic and VIP. Week is on. Choose your edge in NEET UG preparation. Offer ends tonight. HSP 10 is the code. 1 week, 1 shot. Go iconic, go VIP. And see VIP, violet, indigo, purple. You know that coordination chemistry light I have told you. 44,999 onwards, and this is your iconic 13,499 only, kids. Will you share it to everyone, kids? I would like to see that. Yes, you kids will share it to each and everyone, kids. Do let me know. Okay, okay. Now, so all the things got cleared. So ultimately I would like to say, God bless you, kids. Love you, kids. And this is the color wheel, that each and everything you are getting from here. This is really awesome, right? Bye to all of you. God bless you. Love you, kids. Bye bye. Okay. Yeah, PDF I will share. PDF I will share. Immediately, yeah, immediately I will share. Sure, sure, sure. It's me, human. Thank you. Thank you. Sanju, bye. Take care. Naveda, Luffy. Lenges, thank you. Vishal MH, thank you. Tomorrow is, kids, tomorrow you are having your question practice session. So don't forget to come. Question practice session is there tomorrow. Thank you, Sahana. Sahiti 40, thank you. Harni ready, thank you. Pawan, thank you. Good night, Akash. नहीं एक और चैप्टर नहीं बच्चा. This much is more than enough. Thank you, Niveda. Baba means the one who is always taking care of each and everything, the subject, everyone, everything. Yeah, Luffy, very good, very good. Thank you, Luffy. Thank you, Luffy. Pawan, good night. Souvik, good night. Niveda, good night. Sahana, bye bye. Everyone, bye bye, kids. Finally, bye. Sir, you are South Indian. I am Indian. Actually, I am Indian. Bye bye, kids. Sanju, bye. Sahiti, bye.